So hello, everybody. It's my great pleasure to welcome you and to open the AGI Latin American Regional Conference. Next slide, Ira. This is the AGI Latin America Regional Conference. And let me first introduce the AGI. Next slide. The AGI is a worldwide platform for clinical research in ataxias, and it includes all stakeholders in the field, the academic investigators, the patients, and biomedical industry. And the overarching goal is the trial readiness. And here on the slide on the right, you can see our areas of activity: multi-center trial readiness services, meetings, harmonization of outcome measures, and data sharing. Next slide. Why are we organizing regional conferences? Here on this figure, you can see, as an example, the spinocerebellar ataxias. And you can see that there is a worldwide distribution, so they are occurring in all regions in the world. However, when you look to the research activities, in particular clinical trials, it is still very strongly dominated by North America and Europe. And this is one of the goals of the AGI, to change this situation and to involve all regions in the world. And the instrument that we've chosen for that are the regional conferences. With the regional conference, and this is the first one, Latin America. With the regional conferences, we want to give those who do very valuable work at their sites a forum to present themselves, to know each other, and to start collaboration. And I'm very convinced that this will be a very successful conference, and we will continue this series of conferences every year with regional conferences in other regions of the world. Now, final slide. I would give you information of a potential immediate collaboration, and this is the trial site registry. This is an AGI online database of specialized sites that see patients with ataxia, and it holds information relevant to clinical studies, in particular clinical trials, and will be important for industry to select trial sites when they plan trials. And you can see that we already have a good representation also in South America and Brazil, but we can do better and increase. And we invite you all to include your site data into the AGI trial site registry. And if you decide to do so, simply contact Ira Eberhardt. And this is my introduction. I wish everybody a successful meeting.
Are you hearing me well? Okay, because I have some micro issues here. I'm so sorry for you all. This is my failure here. So, hello to everybody around the world. I thank you very much for you to share this moment about Latin America's landscape related to inherited ataxias, and the participation of all these researchers and clinicians in the AGI. So next, in the next few hours, speakers will present to all of us the local characteristics of the 17 different Latin American sites, type of institutions, target population, the diagnosis obtained and followed, as well as the aspirations and needs and obstacles faced by the research and clinical teams. The order of presentation will be alphabetical according to the country name. We will hear heterogeneous contents, of course, as the stages of development and paths are different per site. After 6 to 7 presentations, we will have a question and answer section. Actually, we will have 3 opportunities for this debate. So I ask the participants to use the chat to send their questions just to expedite the process. Live participation will be possible as well if we will have time to do that. So Mario, are you ready? Okay, so I can invite now Mario Cornejo to chair the first round of presentations. Mario Cornejo is neurologist, head of the neurogenetics unit at Instituto Nacional de Ciências Neurológicas in Lima, Peru. Please, Mario, take your step.
Hello, everyone. It's a real pleasure to be with all of you in this regional AGI meeting. We will start right away with our first speaker, and we introduce Professor Marcelo Kaufman. He's a neurologist working at Hospital Ramos Mejia in Buenos Aires, Argentina. Go ahead, Marcelo.
Thank you, Mario. Thank you, Laura. Thank you, Thomas. Good morning, everyone. So it's my pleasure to be here. So briefly, I'm going to present in the next few minutes our experience dealing with genetic ataxia in our center in Argentina. I will start my presentation with results that we published a couple of years ago about the first 11 years of following our patients in our neurogenetic unit in the Hospital Ramos Mejia in Buenos Aires, Argentina. So it's well known by all of you that the genetic heterogeneity has been a barrier to access to molecular testing in our region, and in particular in ataxia. So our main objective when we start seeing this patient and start this program of chronic and progressive genetic ataxia was to find an answer in order to make each test selection more informative and available to all of our patients. As you know, there are more than 50 spinocerebellar ataxia, dominant ataxia. There are more than 60 recessive ataxia. And there has been a large period of delay before all of these patients can access a final diagnosis. When we started this program, the mean diagnostic delay was about 10 years for our cohort. Next, please. So in some way, starting this program and presenting all of these results, we can convert a clinical care program into a national diagnostic data set. So we've been evaluating more than 1,000 patients in a unit during this period of time, these 11 years. Among them, about a third, about 300, were included with a diagnosis of chronic progressive ataxia. They have a mean age at evaluation of 41 years, and about half of them has a positive family history. So we designed a program as a phenotype first, family history driven. We were very resourced, where taking into consideration the economic limitation of our region. Next, please. So the next. So the first diagnostic split in our approach was clinical, not technological. We use the inheritance pattern and the orientative phenotypes in order to assess and change the pretest probability of finding a positive result before ordering a lab request. So the different patients or our cohort was split into autosomal dominant, autosomal recessive, or sporadic without family history. And you can see that is in some way split in similar number of patients. Next, please. So this results in a rational diagnostic algorithm that kept testing aligned with probability, I have said before. So you can see that you start if the family history is suggestive of a autosomal dominant inheritance with the assessment of repeat expansion spinocerebellar ataxia, the most common one, and a first in a first trial. If this test end up being negative, we use next generation sequencing for residual complex or atypical cases. Next, please. So at the end of the day, 1 in 3 patients reach a molecular diagnosis. So our diagnostic yield was about 30%. The overall diagnostic yield was 33.8%. This was more than 100 patients molecular diagnosed at the end of our follow-up. Next. And you can see that this diagnostic yield was significantly larger in those dosages with positive family history, where about half of them end up with a molecular diagnosis. And this yield was significantly lower in sporadic ataxia, at least at the moment of this publication a couple of years ago. Next, please. And in our country, dominant ataxias were led by spinocerebellar ataxia type 2. So we can say that in Argentina, the most frequent dominant spinocerebellar ataxia is spinocerebellar ataxia type 2. There is a very well-known clinical clue that is the presence of markedly slow horizontal saccades that were present in about 75% of our spinocerebellar ataxia type 2 patients. Next, please. The ataxias were dominated by Friedreich ataxia. It's similar in everywhere. 60% of our recessive diagnoses were Friedreich ataxia. And you can see here the heterogeneity of recessive ataxia, where there were, in addition, 12 different genes confirmed as causing other cases of non-Friedreich recessive ataxia. Next, please. So there were some phenotypic red flags or clue that guided molecular choice. As I said, the presence of slow saccades in spinocerebellar ataxia type 2, the presence of macro square waves and hypometric saccades in Friedreich ataxia, the presence of Parkinsonism and polyneuropathy in spinocerebellar ataxia type 3, the presence of myocardiopathy in Friedreich ataxia, and some findings in the MRI were illustrative as well. Next, please. For the remaining hard residual cases, next generation sequences has the power to solve these patients, and 26 require next generation sequencing based assays, and we obtained 65% of diagnostic yield when next generation sequencing was used. The different technologies of different tests based on next generation sequencing were used: panel-based, exome sequencing, whole genome sequencing, whatever. Next, please. And as I said before, the residual cases were genetically diverse. There were different genes in 1 or 2 cases responsible for the rest of the diagnosed patients. Next, please. So molecular diagnosis change care, not only the nomenclature. This allows for a better genetic counseling, better prognosis, information given to our patients, and the cascade testing and reproductive advice in the families familiar members are at risk. Next, please. So this ended up in an algorithm that was a gene panel and was scalable, a diagnostic scalable model to be used in our center and in our country. Next, please. So the next diagnostic frontier is late onset ataxia. So as you know, the last 5 years has been in some way very informative and revolutionary for this group of patients that traditionally were undiagnosed as sporadic idiopathic late onset ataxia. So, as you know, you require different technology for assessing the presence of the large repeat that are responsible for the two main causes of late onset ataxia, that such as CANVAS and FGF14 related ataxia. And so the technology that we are currently using for diagnosing this patient is long-read sequencing based on Oxford nanopore. And this came up in many cases after negative whole exome sequences or negative second generation, next generation sequencing based assays. Next, please. So you have to remember that negative whole exome sequences does not rule out genetic ataxia. So there are a vast number of patients with late onset ataxia caused by these large expansions. So you have to look for this repeat expansion when you are facing a patient with late onset ataxia, and in particular if showing some particular oculomotor signs and vestibular dysfunction. That is subject of another presentation for a reason of time. Next, please. So this is illustrative of one of our patients with spinocerebellar ataxia 27B caused by repeat expansion in FGF14. Next, please. So long-range turned the program from algorithms to assay design. Next, please. Thank you very much to my team, Dolores, Sergio, Patricia, Valentin, Nancy, and the previous fellows and students in my group. Thank you very much.
We thank Marcelo for this presentation. Let's go jump up with the next presentation. Professor Marco Rossi, neurologist from Raúl Carrea Institute for Neurological Research, the Flaney Institute from Buenos Aires, Argentina as well. Go ahead, Malco. You have.
Good morning. Thank you very much for this invitation. I am a movement disorders neurologist working at Flaney, a neurological center in Buenos Aires, Argentina. And I also do research for CONICET, the main government agency for scientific research. Next, please. My clinical and research background on genetic ataxias includes the diagnostic approach for genetic ataxias with clinical algorithms, the use of AI-based tools for the differential diagnosis of genetic ataxias, and we also conducted an epidemiological study of scarce frequency in Argentina, and I also participate in the MDS nomenclature for the genetic ataxias, and we just developed and published online the MDS Gene Ataxia online resource. I am very grateful to my mentors, Bart van der Warenborg, Christine Klein, and Marcelo Merello. So the experience of our group in studying and managing genetic ataxias includes about 100 patients genetically confirmed, mostly SCA2, SCA3, and Friedreich's ataxia. We receive patients from across the country and also from other countries, and we have our own patient databases, and we just started to evaluate patients with rating scales in a standard way, mainly patients with Friedreich's ataxia receiving omaveloxolone. And at our center, we have 3 Tesla MRI. We can also measure neurofilaments, and we just incorporated also Oxford nanopore technologies for long read sequencing and other genetic testing. And we can also do DBS. We have a large and dedicated rehabilitation center. And regarding our local challenges, Argentina is a middle-income country with a population of about 46 million. Next, please. And Buenos Aires and the greater metropolitan area has about 15 million. So we have in Argentina several private and public labs that perform genetic tests like next generation sequencing or repeat expansion detection methods, and also long read sequencing. But unfortunately, we face some important barriers to access to genetic testing because it is usually not financially covered by the health system or only partially. And some patients have access to specific and targeted approaches, but if negative, they cannot continue with more broad testing. So in Argentina, according to genetic studies of ataxia cohorts, we have a high rate of undiagnosed patients ranging between 65% to 82%. And I think we need to test more SCA36 because of Spanish immigration and also RFC1 and SCA27B. So next, please. For the next years, I see some opportunities in clinical research and clinical care, like the possibility in our country to develop a national registry of genetic ataxias, also the possibility of developing a dedicated ataxia center or unit in Argentina. In our country, patients with ataxia generally have access to neurologists, but there are only a few movement disorder specialists that have a dedication and a real interest in ataxia. And there are still no interdisciplinary groups of health and allied health professionals that are exclusively dedicated to treating patients with ataxia. So we also have very few trained genetic counselors. And to finish, I think that we need more research funding opportunities for screening studies on ataxia cohorts. Thank you very much for your attention.
Thank you so much, Malcolm. Such a great presentation, and thank you for keeping time. And then our next speaker is Professor Laura Jardim, our chair. She's a neurologist from the University Federal from Rio Grande do Sul and Hospital de Clínicas de Porto Alegre. Go ahead, Laura.
Thank you, Mario. This is the time of hearing about the experience of on hereditary ataxias in Porto Alegre, Rio Grande do Sul, I would say in the last 30 years. I worked at a medical genetics service, not a neurology service, since 1987 at Hospital de Clínicas de Porto Alegre. This institution is the reference center for the care of ataxia patients in the public health system of Brazil called SUS in Rio Grande do Sul. Next one. Rio Grande do Sul has 11 million inhabitants, whereas our city has 1.5 million of inhabitants. We cover all of those populations. Next one. So in 1989, I identified the first the autosomal dominant families living near here. In 1997, Jorge Sequeiros helped me to send the first samples to be tested at Amaguio in order to be diagnosed soon after the discoveries of the mutations related to these diseases. Next one. In 2001, Maria Luisa Saraiva Pereira standardized the diagnostic techniques for SCA3 and other CEG expansion disease disorders. So since then, we have been performing these tests in-house and offering to SUS, to the public health system. At the same time, a large number of families and individuals were looking for care because they were ataxics. So next, please. So soon we detected by 2000 a large population of Machado Joseph disease or SCA3 living in our region. And in all those years, we added these people in our registries, in our database. So by 2020, we went to them, asked how many of them were living in their families, and find that 760 symptomatic subjects were living in our region. Next, leading to the farmer slide, leading to a prevalence rate of only of SCA3 of 7 individuals, symptomatic individuals per 100,000 inhabitants, and circa of, I would say, 15 at-risk subjects also in this population. So this map, this geographic distribution of the families with MJD of SCA3 portrays somehow the next slide, please, portrays somehow the occupation done by Azorians when they came in. They have been sent here by the Portuguese crown in 18th century in order to occupy this territory. And indeed, I would say that I need to say that Azorian couples actually funded our city in 1772. So next slide, please. In all those years, 20-year scenario, we have the opportunity of producing maybe 100 papers related to CG expanded repeats and also other kinds of expanded repeats like ATTCT and SKTN. And our lines included, the designers of the studies included epidemiological studies as well as clinical reports relating to mainly to natural history studies, longitudinal observations, but also design of a clinical scale and a new statistical modeling. Then we move also to formal genetics, looking for explanations why these diseases are maintained in the population, so selective forces, mutational origins, as well as modifying factors, either genes and environment, biomarkers to be used in longitudinal studies to come moreover, especially those clinical trials, and then some clinical trials, either open label and double-blind, double-blind clinical trial. And to finish the story, also we presented our experience about presymptomatic testing. I am a little bit proud of that because most of these studies have been done autochtonously. I mean, most of these studies have been done here inside in our institution, either the clinical as well as molecular studies. But at the same time, next slide, we looked for international collaboration, mostly those funded by bilateral public funding. And we obtained that in relationship to European and as well as US agencies. Unfortunately, not with Latin American, with other Latin American countries. To finish also this story of collaboration, next slide, please. We also looked for some networking to increase access. And I would say that the most successful experience was on Rede Neurogenética, in which we performed diagnosis to other colleagues from Brazil and other countries in Latin America, and then presented this kind of distribution patterns. After that, some years later, and together with many colleagues that are today with us, we launched this Pan-American Hereditary Ataxia Network without any funding, but we were able to also to describe these differences in between the countries of our continents. And to arrive today here in this collaboration with AGI, Ataxia Global Initiative, for which we are very grateful. For instance, we are performing this meeting today because of the AGI that, of course, have the aim of facilitating new trials on spinocerebellar, or I would say on hereditary ataxias all over the world. So next one, please. I just wanted, because everybody is waiting for that, to say the state of the art of the inherited ataxias in our institution and region as well. So in relationship to SCAs or to families with autosomal dominant patterns, in between 2000 and 2006, sorry, we have registered 1,316 symptomatic patients belonging to 328 families with definite autosomal dominant patterns. And between them, the next one, please. 256 families carried mutations in ATXN3, so they have Machado-Joseph disease. So this is the huge number, concerning 78% of our families. But we have also all this other diagnosis. The second one is SCAT2, third SCAT10, etc. Thank you. And only 11 families without diagnosis in this large cohort. Next one, and next one. You can move a little, one more, please. And in relationship to recessive ataxias, we have finished recently a retrospective review of our experience from 2003 to 2020, and then next we reached a number 10 times shorter. The next, please, the next slide. 10 times shorter than autosomal dominant individuals or families. Only 174 subjects look at us without a vertical story in their families. From these 174, only 57 finished their diagnostic workout. I mean, either because they got a diagnosis or because the NGS study gave negative results for those guys. So in between this, I would say ataxia forms without vertical inheritance. We had something like 80% of diagnosis, whereas the other 20% didn't reach any explanation. So given rise to this pie, please, the next slide, the former, yeah, in which you can see that, again, as expected, Friedreich ataxia was the most frequent, 17 families, followed by no diagnosis at all, followed by ataxia telangiectasia, and so on, so on. I would like to stress that, of course, we found two dominant forms because the inclusion criteria was to do not have a vertical inheritance. So we found two families with two individuals with SCA2 and one individual with SCA27B. Next. I'd just like to stress, to take the opportunity of today to stress the importance of care, to offer care to these families and individuals. And in my opinion, the most important care that we can offer to the families with CAS is genetic counseling and definitely presymptomatic testing. We have this experience on presymptomatic testing for the last 20 years. I can tell you that 10% of individuals at risk looked for this information. And for those that looked for the information, half of them actually performed the test. So showing that they do if they need or if they want that. And I hope we are not the only institution in our country that are performing, but I'm afraid maybe they can be the same. So please tell me if you are doing presymptomatic testing in your institutions as well. So to say that, I would like to thank you and present the last but not least slide to say thank you to my students, the staff that are working on diagnosis in my institution, and you all. Thank you.
Thank you, Laura, for that comprehensive presentation. Our next speaker is Professor Elliot Teibe. He's a neurologist from Universidad Federal do Paraná and Hospital de Clínicas de Curitiba, from Curitiba. Go ahead, Elliot.
My hereditary ataxia outpatient clinic takes care of 16 patients every week, including a protocol, established protocol, clinical assessment, protocols for autosomal recessive cerebral ataxias, autosomal dominant, X-linked and mitochondrial ataxia, including routine MRI, molecular genetic exams in collaboration with other national and international centers, symptomatic treatment, and genetic counseling. The story of this outpatient clinic, the outpatient clinic, in my outpatient clinic, Ataxias, outpatient clinic was created in 1989 in the Hospital de Clínicas of Federal University with my colleague, Professor Walter Arruda, and I. And at this time, we had a support of Professor Anita Jardim from Institute of Neurology in King's Square, London. And then we published several papers about, particularly in hereditary ataxia, but particularly in spinocerebellar ataxias, including today more than 208 families, including more than 600 patients. These slides demonstrate the first family published in Brazil with Machado Joseph disease, SCA3, in 1991. And then Our group participated of several meetings, including the third international workshop on Machado Joseph disease that took place in the São Miguel in the Azorian Islands in 1994. This presentation had the support of Professor Paula Coutinho group, including Professor Paula Coutinho and George Sequeiros, the organizing meeting. But we have several collaboration with Professor Guy Rouleau from McGill University. In 1997, we organized the fourth international workshop on Machado Joseph disease that took place in Curitiba, the fourth international workshop on Machado Joseph disease. I think the most important contributive study in this area of our group was the publication of the first case of spinocerebellar ataxia type 10 in Brazil, in South America, in collaboration with Professor Tetsuo Ashizawa at that time in the Baylor College of Medicine. After that, we published several papers about spinocerebellar ataxia type 10 with Professor Tetsuo Ashizawa, including a large study with 16 Brazilian families with SCA10, more than 100 patients, including the studies about the frequency of epilepsy in this sample of Brazilian patients, because if you compare SCA10 in Mexico and SCA10 in Curitiba, south of Brazil, there are a big difference because the phenotype in Mexico is including cerebellar ataxia associated with epilepsy, and in our patients, it's pure cerebellar syndrome without epilepsy in most percentage of cases. The reason about this difference, different phenotype, could be the presence of interruptions in the SCA10 gene, ATT, CT, repeat expansion, and these studies published in collaboration with Professor Ashizawa group and more recently with the Professor Laura Jardim group proved this association of interruptions in the gene and the phenotype with or without epilepsy. Another studies in hereditary ataxias, including SCA2, were performed in collaboration with Professor Stephen Pulse from Utah University, and more recently, together, Professor Zbigniew Zaleski from the Mayo Clinic of Jacksonville, US, in SCA7, and more recently, a collaborative study together, Professor Holden from King Square, the National Hospital in London, King Square, published 3 years ago about the frequency of SCA27B in Brazil in collaboration with another groups, Brazilian groups. The future perspectives we are starting a new collaborative study with a group of Professor Birgit Schuy, Stanford University in California. We create a new study. The acronym is TUPAN, SCA10, Striking Unique Patterns in Ataxia Type 10. This study is started this year. And now our group start a collaborative genome sequencing study with the genetics laboratory of the Oswaldo Cruz Foundation, Fiocruz, in Curitiba, Paraná, Brazil. And the future perspectives include to maintain and expand collaboration with national and international study groups on hereditary ataxia. I would like to make some acknowledgements to the Ataxia Global Initiative for the invitation to participate of this meeting, the AGI in Latin America, represented by Professor Laura Jardim for the kind invitation, and to our research groups studying hereditary ataxia in Brazil and internationally for the collaborative study conducted over the years, including late Professor Nita Harding, late Professor Paula Coutinho, Professor Jorge Sequeiros, Professor Guy Rouleau, Isia Lopes Sandes for Unicamp, Salmo Paz came from Curitiba, Tetsuba Shizawa, Stephen Post, Zbigniew Zolek, Henry Holden from UK, Laura Jardim from Porto Alegre, Marcondes França from Unicamp, and now Birgit Schulz from Stanford University. Thank you very much for your kind attention.
Thank you, Professor Teibe. Let's move to the next speaker. We present now Professor Marcondes França, his neurologist from Unicamp Campinas. Let's go ahead, Professor Marcondes.
Well, thank you, Mario. Thank you, Laura, for the introduction and for the invitation to join this initiative, which is really good to see what's going on in terms of ataxia investigation in Latin America. So I'm going to present on behalf of my group at Unicamp, but also I'm going to present some slides with the data from Unifesp. So this is another very important center in Brazil, led by Professors Pedroso and Bassottini. So moving on, no disclosures. I'm just present some data. These were funded by either Brazilian governmental agencies, but also by some international entities, especially FERA. And so beginning with Unicamp. So Unicamp is a university based in the southeastern part of Brazil. So it's located in the state of São Paulo. So you can see here the precise location of Campinas. So our hospital is a national reference center for neurogenetic diseases. This has been labeled by the Brazilian Ministry of Health. So we've been formally entitled to be labeled as a national reference center for neurogenetic diseases. And the overall coverage of our hospital is around 5 million people in our region. But, thinking about ataxias, we actually see patients from, all over the country. So we see patients coming from other regions, not only those living close to Campinas. Our center was established in 1997. So Professor Teibe already mentioned Professor Lopes Sandes, which has been my mentor, my PhD advisor. So she's a neurogeneticist. She trained under Professor Guy Rouleau in Montreal, in Canada. And when she came back to Brazil, she established this clinic, which was one of the first clinics in Brazil. In addition to establishing the clinics, so Professor Lopes Sandes actually established a molecular biology laboratory, and she this was one of the first Brazilian centers to provide genetic testing for SCAS and for Friedreich ataxia. So for many years, many patients came to see us, and eventually many samples from patients around Brazil came to our center to get tested. So I took over the leading of this clinic in 2019. So I'm now the current chair of the Ataxia Center. Since then, our center became a member of international collaborative efforts such as AGI and such as Unify for Friedreich ataxia. And more recently, we've been also involved in clinical research for ataxias. We took part in 4 clinical trials at this point, and we still have 1 pending to begin. So in addition to clinical assistance, academic studies, we're now taking part in this, clinical trials for ataxias. So our team, so this is the core, research team that we have in our center. So I'm the leader of the team, but also we also have Professor Alberto Martinez, which is an assistant professor at our hospital, and Dr. Luisa Piovesana, so 3 neurologists. We have 2 molecular biologists in the laboratory, so Dr. Adriana Vinagre and Dr. Cynthia Silveira. 1 medical physicist, Thiago Rezende, which is known by many of you. So Thiago has been doing a great job in terms of, running many of our, imaging studies, and 1 physical therapist, Dr. Raquel Guimarães. So this is the core research team. Of course, we also have some, investigators which are, in training. So you can see here our large group here. So many PhD students, postdocs. So we now have a very large research team at our institution. And funding, we of course have, funding from Brazilian agencies such as FAPESP, CNPq, but more recently we're able to get the funding from, international institutions such as FERA, which has been really supportive to our research efforts, and also the Spastic Paraplegia Foundation from the United States. In terms of our overall infrastructures or facilities, we have the clinic, which is of course the basis of what we do in terms of clinical activities. So it takes place every Friday in the afternoon. We typically see more than 500 patients per year. So this is the overall, number of patients seen in 1 year. We also have a neuroimaging laboratory, and where we have a fully research dedicated Philips scanner, so basically use it for research activities. We also have this molecular biology laboratory where we are able to run next generation sequencing investigation, and we also do locally expansion genotyping, including the more recent ataxias such as Ca27b, Canvas, and so on. And more recently, we were able to expand what we do in terms of basic investigation. We now have a cell culture laboratory, which became recently active, and we expect to have more, functional investigations done in our research center. In terms of our cohorts, so this is what we have so far. So almost 900, subjects with ataxia in this huge interval between 1997 and the last year. You can see here the share. So we have a cohort of patients with recessive ataxia, around 340 patients, and almost 500 patients with SCAS. So this is the overall share we have in our center. And in terms of research, so we do have some special interests in terms of research. So the first one, of course, is to characterize the epidemiology of ataxias in Brazil. So we took part in initiatives led by other researchers in Brazil to try to somehow characterize the relative frequency of the main SCAS in our country. I'd like to draw your attention to one specific. We in these past few years we had the chance of publishing a lot of papers. Most of these papers were in collaboration and included papers published in important journals such as Annals of Neurology, Movement Disorders, GNNP, and Cerebellum. Talking about this characterization of the epidemiology of ataxias in Brazil, I think one important contribution, I believe, from our center is that we're able to establish locally genetic testing for some of the recent ataxias. So we're now able, for example, to genotype for Ca27b. So we don't need to send the samples to get tested abroad. So we can do this locally. You can see here, for example, pretty nice examples of TP-PCR done in our laboratory, and this has been done in a huge collaboration between other Brazilian centers such as Unifesp, USP at Ribeirão Preto, and of course, and also Curitiba with Professor Hélio Teivi. In addition to this epidemiology interest, we also have interest in the deep phenotyping of ataxias, and I would say that one special area of interest in our group has been the characterization of non-motor manifestations, such as sleep disorders, looking at fatigue, cognitive aspects, and so on. But definitely, I think the most active area of research in our group has been the identification of biomarkers and somehow trying to characterize the natural history of ataxias. And we have efforts using inertial movement sensors, looking at fluid biomarkers such as microRNAs. But definitely, I think the most active area in our group has been neuroimaging. So neuroimaging in our group has special focus on SCA1, 3, 6, 27b, Canvas, and Friedreich's. We've been able to conduct studies using this kind of multimodal approach, addressing the brain, but also the spinal cord. And we were glad to be part of international collaborations such as Enigma, ESME, and more recently, Track-of-Fate. In addition to looking at the patients and having clinical data, we've been also able to develop tools to be used in ataxia research. For example, Thiago has been working very actively in the development of, for example, of QSM protocols that enables the segmentation of the dentate nucleus, and this has been really interesting, especially in FA. So we have this huge interest in terms of imaging. You can see here, for example, one of our publications, one that I've been proud of, which is one of the first studies looking at the structural signature of SCA3. We're able to gather a pretty large cohort of patients from pre-symptomatic to those in the late disease stages, and doing this kind of pseudo longitudinal approach, we're able to see how the disease eventually progresses from the initial stages up to the late stages. And you can see that it begins in the lower portions of the CNS and then evolves up to the cortex in these subjects. And the same takes place for the cerebellum. So you can see that initial stages, pretty mild damage, and then in the late stages, quite widespread damage to the cerebellum. We also have had a chance to lead the first study trying to characterize what goes on in the brain of patients with Canvas. This has been published 4 years ago in Movement Disorders. You can see here the overall pattern of damage in this subject. So imaging has been definitely one area of great interest in our group, and I think we have been able to contribute with original data in this context. So now moving briefly about Unifesp. So this is a center based in São Paulo, the capital of the state of São Paulo. Hospital São Paulo is a pretty, important reference center for neurology. This is the group, so led by Professors Pedroso and Bassottini. So they also have a pretty active research team there. And they have published recently in Brazil a very, very interesting report showing the overall experience in this center. As you can see in this publication, a very large cohort has been following in that center, more than 1,000 patients with different types of ataxias. As you can see here, rare ataxias have been found, but also other types of ataxias, including, of course, many cases of genetic ataxias. As you can see here, for example, SCA3, SCA2, SCA7, and so on. The research in that center has been focused on the characterization of the ataxias in Brazil. More recently, they've been trying to use new genetic tools to determine the genetic basis of ataxias in their center, with the introduction of long-read sequencing and the search for new expansions. And this has been done also in collaboration with our group, for example. So these are the specific projects that have been done at Unifesp. So new genetic techniques, investigation of SCAs with point mutations, again, investigation of cognitive aspects of ataxias, and focus on specific subtypes of ataxias, such as those connected to ATP1A3 and for example, RSACs. So this is the overall profile of Unifesp, a very important center in our country, and one very, very active partner of research with our own group at Unicamp. So I'd like to finish here. Thanks for the opportunity. And I'm now finishing my presentation. Thank you.
Thank you, Professor Marcondes. Wonderful presentation. Let's go to our next speaker, Professor Maria Carolina Gamini. She's neurologist from Rede Sara Kubitschek. Is that correct? Rio de Janeiro. Go ahead, Maria Carolina.
Good morning, everyone. Do you hear me well? Okay, next one, please. I'm Maria Carolina. I'm a neurologist at SARA Network of Rehabilitation Hospitals in Rio de Janeiro, Brazil. Next, please. I'm part of an ataxia outpatient clinic and part of a multidisciplinary team composed by physical therapists, neurologists, and the support of a geneticist. Next. For the past 9 years, we've attended 500 ataxic patients with around 800 consultations per year. Most of them have spinocerebellar ataxia, even though other genetic etiologies are being identified due to the large availability of NGS panels. We also attend different types of recessive ataxia, mainly Friedreich's ataxia, and ataxia occurring as manifestation of other neurogenetic disorders. Nevertheless, around 20% of our patients remain with unknown etiology. Next, please. In regards to scientific research, in 2022, we did a multi-center study analyzing the frequency of expansion SCAs in Brazil. Analyzed also the clinical and epidemiological aspects and their correlation with the size of the expansion. Next. In 2025, we presented a study in the MDS Congress addressing the effects of an intensive rehabilitation program in patients with spinocerebellar ataxia. Next. A lot of research lines are being developed, mainly the prevalence of Friedreich's ataxia in Brazil, the association between SCA2 intermediate expansions and amyotrophic lateral sclerosis, the evaluation of impulsivity symptoms in SCAs, and the assessment of osteosarcopenia in patients with hereditary ataxias. Next. In our clinical experience, and on the other hand, we face several challenges on the diagnosis based on genetic testing, mainly the limited access to NGS panels and the high cost of whole exome sequencing. Also, the presence of VUS and findings that do not fully explain the clinical phenotype. Next. Between May 2023 and December 2025, 72 NGS panels were performed. 27% were positive, and more than half of them presented VUS, in which 22% were responsible for the clinical phenotype. Next. In perspective to rehabilitation, we also face challenges in recruiting patients to rehabilitation program, largely due to social barriers as low educational and economic levels and difficulty in commuting to our hospital, as well as disease severity of our patients. This also impacts in low attendance and adherence to treatment programs. Next. I would like to thank the organizing committee for the kind invitation and for the opportunity to exchange experience to have these meaningful discussions. Thank you.
Thank you, Maria Carolina, and thank you all the speakers for these very nice presentations in this first session. So right now we're gonna start with the questions and answers session, and we really want the active collaboration and participation of all the attendees. Questions, please, for our presenters. Today in this first session, we had presenters from Brazil, from Argentina. Any questions from them? You can write them, or you can also introduce yourself and present them briefly as well. I think microphones will all be open as well if you require. We have a first question here. I think it's for any one of the presenters. Is there any research into ataxia SPG7? Any specific research initiative for ataxia SPG7?
I may begin.
Okay, go ahead, Marcos. Thanks.
So we do have a research going on, which has been funded by Spastic Paraplegia Foundation from the US. So this is a study where we're looking at biomarkers for SPG7, again, with a special focus on neuroimaging. So this is going on. This is a longitudinal assessment of SPG7 patients, looking at especially the spinal cord imaging to see whether we can capture disease progression. So no kind of, this is not a therapeutic investigation, actually looking at biomarkers, but this is going on in our center right now.
Thank you, Marcondes. I will start with a question for the speakers. And since we have two groups, one from Brazil and the other from Argentina, my first question is, what are your experiences working together, for example, in your country as a network or with collaborative studies across Brazil? And the same thing for the Argentinians groups. And also, if we have any previous experience working internationally across Latin America.
So, but thank you for the question, Mario. That was one of the objectives of this meeting and this presentation to encourage the collaboration. So in Argentina, we have experience in collaboration. We are a referral center for ataxia, so we receive many patients from different colleagues in the country. And in particular, for the development of long-read sequencing for late-onset ataxia, as I show at the end of the presentation, we've been actively working together with Marco in Fleni. We received some patients from his center in order to assess the presence of the expansion in this patient. And in the region, especially with you, Mario, we have a very, very active talks and discussion about our patient, and we have some patients in common. And in Brazil as well, we've been working together with Jose Luis Pedroso and Orlando Barsottini. We have some exchange of fellow in one occasion. So I think the collaborations in the region are ongoing, but I think it can be much larger and much better if we repeat this type of event and encourage the collaboration for all of the region.
I agree with with Marcelo. I also want to add that Marcelo also and his group collaborated with us, with our group, on a project we just published on movement disorders about an AI-based tool for the differential diagnosis of the chronic ataxias. And so we are planning to also continue collaborating with Marcelo and his group on the next part of this project. And I also want to add that I also had the opportunity in the last years to start working together with José Luis Pedroso and Orlando Barsottini, also with a great experience, and just thank them for actively collaborating with us.
Any of the Brazilian speakers want to share experience about collaboration across Brazil?
I think I addressed this this question a little bit during my 1 minute slide on this topic. I think this is dramatically important, not only to the research, but also to the assistance level. So we are aware that good laboratories to perform diagnosis are those who have some large experiences in those techniques. So we need a centralization of some investigation or diagnostic levels as well, not only in the research level. But, and I mentioned our experience here, Mario, with Rede Neurogenética and whatever, and also some of these collaborations funded by national agencies from Brazil and other countries. I was about to say at the end of this meeting today, I would suggest us, maybe you can agree with me, that we can maybe write a letter to the authorities of each of our countries, related, of course, to the research ministries or secretaries. I don't know the name of each government about it, doing a report on this meeting, showing that we have large interest in tightening our relationships and asking these authorities to launch new calls and in order to help us to have this share of experiences in research as well as in assistance. Okay, but I can come back again to this suggestion later today. Thank you.
Thank you, Laura. We have one question in the chat regarding, do you have any issues regarding recruiting patients into any projects? I imagine they are referring to recruiting participants for research projects in ataxia. What are your experience, especially, I mean, the big centers that are recruiting participants, probably for clinical trials or for other kinds of studies? What is your experience on recruitment?
I don't know what are they meaning by issue. So obviously there has been some general issues with different research. So especially at the very beginning, when you have to educate the institution in order to pay attention to the requirement for doing research, but I think now in our center and in the majority of the center, the experience is enough. Is enough in our institution to be more supporting of research and more supporting of giving the resources for conducting this type of research. So I think in the present there are not, at least in our center, major issues for recruiting patients for our studies.
Thank you, Marcelo. We have another question also here. Where to test patients for RFC1 in Latin America? Thank you for your presentations. That's a good question. So which center is offering genetic testing for Canvas?
We're doing this in our center, Mario. So
We also do at Sarah. We also do it there.
We are finishing the development for RFC1 and FGF14. So in the second half of this year, we will be able to offer the test.
But just to comment, so it's a little bit challenging to test for FC1 because we now know that there are additional motifs, not a single one. So you should be really careful about that. And, you know, more recently, we've been able to see also point mutations. So in order to do a very comprehensive evaluation, it's not really, I mean, that straightforward, but I mean, it's something we can do. Yeah.
Can I add something about
Your turn on.
Thank you. Can I add something about the barriers to recruiting patients for studies? Recently, we did this study of intensive rehabilitation program, chiefed by a physical therapist, Fernando Coimbra, and we have had a lot of difficulty recruiting patients. Initially, we have around 300 patients, but we only managed to recruit around 70 patients and lost like 10 of them throughout the 4 weeks of intervention, mainly because patients have a lot of difficulty to come to the hospital. Our hospital is located in a more far away area, and patients have a lot of economic difficulty to get public transportations and have family members that can come with them. So we have had a lot of difficulties in adherence to the program. And we also encounter this difficulty in rehabilitation program in our daily basis. So that's it. Thank you.
Thank you, Maria Carolina. Just a brief comment that we have a nice presentation from Katiana that represents the Brazilian Association of Hereditary and Acquired Ataxias. There's the contact information in the chat. I think most of the researchers, especially from Brazil, might be interested to work and collaborate with that association, I imagine. That will be also important. And I have two questions, one perhaps for Laura in first place, but for the other speakers as well regarding the pre-symptomatic testing for ataxias. So what was the experience of your center, Laura, on pre-symptomatic testing, and for the rest of the centers, if you are also conducting pre-symptomatic testing on inherited ataxias?
So our experience is, as I said, is a 20 years experience. And most of our patients come from, of course, from Machado Joseph families, but as well from Huntington's, SCA7, even SCA10, familial amyloid polyneuropathy, and whatever, these neurodegenerative disorders of late onset. And not Friedreich's, because Friedreich's are usually an early onset disease, so it's not also related to large families. There is no recurrency between those families. If they were, maybe we could offer as well. We have a team and a program. This program consisted of 2 consultations to give genetic counseling to clarify the aims and the limitations of what to do with the test. Then, if the subject continues continues wanting to perform the test, then the 2 blood tests are collected just in order to avoid any difficulties with just one blood sample. And when the test is ready, we phone them to say, this is ready. If you want to see, come and see the result, please come. This usually takes 1 to 2 months. And then patients come and receive. As I said, 50% of subjects that come in order to receive this genetic counseling and information in relationship to pre-symptomatic testing, half of them actually continues the program and moves towards the end. And I don't know how many we have now, because I didn't go to this data file. It's a very protected data file. Actually, it's not open to myself, just in order to safety issues. Yeah, and I think this is a very important alternative to offer to those subjects, but because the information belonged to them, and they wanted, some of them needed this information in order to organize their lives. And that's my point. So it's not up to us to decide what is better for each individual. Human being, it has the right to know or not whatever it's concerned with their own genetic status or background. And that's it. This is my opinion and as well my experience.
I fully agree. I fully agree with Laura. So the experience in our center is similar. It's a very personal decision, so it's part of the genetic counseling process. So there is no general answer of it depends on the desire, values, and the internal decision of each member of these families.
But of course,
Thank you, Marcelo.
sorry, I would just add, of course, it adds another complexity to our tasks. Yeah, you need to have a multi-organized team. You need to have a counselor. You need to have psychologists. You need to have fully background organized. So it may be complicated for each one of us, but I think this is one of our destinies to perform in our clinics.
Yes, it's a teamwork. It's not.
Yeah. There's another question regarding prenatal testing and pre-implantational diagnosis in ataxias. Does anyone of the speakers of this first session want to address this question? Prenatal testing, pre-implantation. Go ahead, Laura.
I will say some words. Pregnancy terminations in Brazil are allowed only in quite a few situations. In the case of anencephaly, in the case of rape, and in the case that the mother is at risk, the life of the mother is at risk. Because of that, we are not allowed to perform prenatal testing, unfortunately, due to this legal reasons. Yeah. It has been done, but not, it was just once in very early time. And that in relationship to pre-implantation diagnosis, this has been performed including our disorders, but on a private system and not in the public health system.
Okay, thank you so much, Laura. I don't know if Professor Tate is ready with the speaker. Well,
I would suggest that Daniana Ruiz present her question again when Pedro Braga will present his experience. She is asking about cognitive neuropsychiatric symptoms in South America. So of course we have, but I suppose that the best person to talk about it is Pedro.
That's gonna be awesome.
When compared to myself, not your, comparing to myself.
Well, I think Professor Tate is having some trouble, but there's another open question for all the speakers, and I think that's also important because you, at the end of your talks, all of you were acknowledging the work of your team, your trainees, your students, your fellows. And so anyone can share a little bit about training opportunities in ataxia in Latin America. So how can we as researchers can collaborate and contribute to train the next generation of clinicians and researchers?
Well, my institution, I'm sorry, I will be brief. My institution offers trainee after residencies. If you have a residency in neurology or in medical genetics, you can apply for 1 year trainee in neurogenetics clinics. So at this very moment, we have two individuals doing this fellowship together with us.
In Sarah Rio, we also have a program that receives neurologists and residents to gain experience in rehabilitation and also participates in our ataxia outpatient clinic. So we will be glad to welcome some of these doctors as well.
We also have fellows. They usually apply through the MDS that has a program for fellows, but this is not focused on ataxia. This is These are fellowships on movement disorders, and fellows get trained in other aspects of movement disorders that includes ataxia.
Thank you, Marco. Marco, on this also want to share.
Yeah, so in our case, it's a little bit different. We also have a training after residency, but we're actually more neuromuscular group. So the training that we have in our center is actually neuromuscular with neurogenetics. So ataxia in our center is connected to neuromusculars in general. So we have two programs. So one, which is a formal medical residency, where they are able to stay for 2 years with us. But we also have an additional 1-year fellowship, which is, only, focused on more neurogenetics in ataxia. So we can do that. Yeah.
I think we have some minutes, but Professor Paula Safi, that is presenting in the next session, want to address also this question if we have some time. Go ahead, Paula. We want to share about the training experience in Chile.
Thank you very much. So I would say with a lot of personal experience that the best place to train in this in ataxias is in Brazil. It's not that I have something with Brazil, but they have the most experienced centers. So what I did, because I wanted to train in ataxia, but mostly in genetics, I had to go the long way. So I did my PhD in Porto Alegre, in Universidad Federal do Rio Grande do Sul. And it was in genetics for Parkinson's, but then we can apply everything to ataxia. So I would say for other colleagues that if they don't have the opportunity to train specifically in ataxia, they need the training in genetics. So I would strongly suggest that they try it any way possible for Latin America, and then you can get to ataxia if you're not in Brazil and you don't have these specifics for doing it in ataxia in Brazil or in Argentina. But for me, it was a great experience, and I should encourage everyone to go for it. It's difficult, but you have to try it for our patients.
Thank you so much, Paula. That is wonderful. And that answers one question, because the question was if Brazil accepts, for example, international students. And obviously, Paula herself is a good example, a great example of that. I want to also thank Mariano Landa from the Ataxia Association of Argentina that is also sharing contact information and also the website. They are an NGO working with ataxia patients in Argentina. Contact information is in the chat. I think we are getting to the end of this first session. Thank you all the speakers for this excellent and wonderful morning, good suggestions and good comments. And I think the most important thing is that we really need to work together and produce something together, having and putting patients and families always in first place.
So, hi again to everybody here. We are about to start the second section of our meeting today. And I would like to introduce the next speaker, Professor Luis Velázquez Pérez from Cuba, who is a neurologist and is actually nowadays the Cuban Academy of Science leader, the head of the Cuban Academy of Science, as well as the Cuban Network of Ataxias in Havana. Please move forward.
Participating in this meeting. And my presentation today will be about building a clinical trial network for hereditary ataxia lesson from the Cuban Ataxia project. And in Cuba, we have identified 2,000 SCA2 patients and 10,000 descendant and risk. Also, every year, 35 new SCA2 subjects are diagnosed and 20 patients die due to the disease. 25% of cases had juvenile onset, and the clinical course to disability is about 10 years. In the Cuban map, you can see that families affected by SK2 have spread across the whole country. That is why the SK2 is considered a very important health problem in Cuba, and for this reason, we funded in 2000 the National Center of Ataxia in Holguin province with the objective to provide medical care and conducted basic to transnational research. Here you can observe the main contribution of the Cuban Ataxia project in relation to epidemiological and molecular assessments. And in Cuba, we made 4 epidemiological studies, 2 of them covering the whole country and showing a national prevalence rate of 36 SK2 subjects per 100,000 inhabitants. It is considered the highest prevalence rate reported in a country at worldwide. Also, we have developed epidemiological studies in other countries, for example, in Mexico and Venezuela. This finding emphasizes the Cuban leading role in the epidemiology of SK and highlighting the significant public health impact of this disorder across different countries. This slide summarizes some of the key molecular contributions of the Cuban Ataxia project. They including the localization of the locus for SK2 disease on the long arm of the chromosome number 12, the characterization of the specific mutation that causes SK2 ataxia, and also it was demonstrated that the larger alleles of SK6 modify the age at onset of SK2 patient. The creation of an animal model of SK2 in Cuba expressing the gene with 75 CU repeat, and the long normal alleles are the main cause of the new SK2 mutation in Cuba, and the identification of the peripheral inflammation marker in SK2 patient related with the cognitive disorder, and the implementation of the predictive molecular predictive diagnosis benefits over 2,000 patients from more than 150 families. This slide summarizes the comprehensive characterization of the phenotype of SCA2, including clinical and electrophysiological assessments. We evaluated around 300 patients and all showed a cerebellar syndrome. On the other hand, the non-cerebellar disorders, including the slowing of saccade eye movement, in about 95%, which is possible to identify before ataxia onset. Peripheral neuropathy, amyotrophy, sleep disturbance, and cognitive disorder are other non-cerebellar manifestations detected in our cohort. The final state of the disease is a very dramatic situation because the patient cannot speak, they have severe dysphagia affecting the feeding. Here you can see the biomarker classification in SCA2 according to the nature of the measurement and including the clinical, imaging, digital, genetic damage, electrophysiological, and multimodal biomarkers. An example of this biomarker are the digital parameter, which is a very revolutionary technology in which we conducted a cross-sectional evaluation in a large binational Cuban-United States cohort, as well as independent Cuban cohorts, with the objective to identify subtle cerebellar abnormalities in SK subjects from healthy controls. Our results showing that the increase of gait variability is the most important digital parameter of the SCA8, supporting their value for evaluating the progression of the disease. Look at here the main contribution of our project in relation to the identification of the electrophysiological biomarker. They confront 7 cross-sectional evaluation and 6 longitudinal follow-up study, resulting the most relevant of this evaluation, the increasing of the central motor conduction time suggested the degeneration of the corticospinal tract, REM sleep pathology, the decrease of the sensory nerve amplitude, and the saccade slowing. Here's I am showing you the main contribution of the Cuban Ataxia project concerning the prodromal description of SCA2, including the time sequence relating with the ataxia onset of the clinical and electrophysiological finding. For example, the early state is defined by the saccade slowing and REM sleep abnormality detecting 15 years before ataxia onset, and the subtle cerebellar manifestation appears between 5 to 10 years before ataxia onset. Near to close of ataxia onset, the MRI demonstrated the pontocerebellar and the mild cortical atrophy. In relation to the contribution of our project to therapeutic approach, I would like to say that we carried out a clinical intervention in SCA2 subjects involving nearly 300 patients and 31 preclinical subjects. And one of the most important or most safe clinical trial carried out in our SCA2 population was the use of neuroEPO, which is a neuroprotector, which exhibited a small clinical effect on motor and cognitive abnormalities after 6 months of the treatment. The rehabilitation intervention improved subtle motor coordination in preclinical subjects and reduced SARA scores in symptomatic patients. The rehabilitation should be integrated with future disease-modified therapy, and the Cuban SCA2 population represents one of the world's most valuable human platforms for hereditary ataxia trials. At the end of my presentation, I have 2 important messages. The Cuban Ataxia project is a model for the comprehensive management of neurodegenerative disorders that could be useful to other regions of the world. The second one, Cuba provides an homogeneous cohort that has been well studied, as well as organizational expertise and strategic vision to an international network. I would like to thank to our patient and preclinical subjects, also to our ataxia research team from Jardim and Havana. Also, I would like to thank to the international collaborator from Germany, United States, Mexico, and Australia. Thank you so much for your attention.
So, thank you very much for this wonderful presentation, not only presentation, but wonderful work. Your achievements are outstanding and helped all mankind as we expect from Cuban people as well. Okay, I am aware that Luis Velasquez Perez could not be together with us, but Roberto Rodrigues will reply to the questions when we achieve the question and answer moment for this section. So I can now move forward. I suppose that Pedro is here. I cannot see him.
He was here, yes. Yeah, he is here.
Pedro is there. So I now would like to introduce from Brazil, Pedro Braga Neto. Pedro Braga Neto is neurologist related to the Universidade Federal do Ceará, a state to the north part of our country, from Fortaleza, so Fortaleza city. So please, Pedro, take the step and talk a little bit to us.
So my name is Pedro Braga. Nowadays I live in Northeast Brazil, my hometown, Fortaleza, Ceará. And today will present my experience as ataxia research in São Paulo initially, where I worked a lot there, and then I come back to my hometown, Fortaleza, years ago. I will focus on my the challenge of ataxia studies in Brazil, my scientific trajectory, innovations, how to build an ataxia unit, and our cohort now, and our current research horizons too. As you know, ataxias are a highly heterogeneous and often neglected disorder. We also face extremely limited access to diagnostic tools in our place in Northeast Brazil. The study of ataxias creates important diagnostic and therapeutic challenges, but also a unique opportunity to build impactful research in underserved regions like Ceará, Fortaleza. Ataxias, just a moment. I began my work with ataxia in São Paulo, Unifesp. Marcondes has already showed you the ataxia unit at Unifesp. At that time, research in ataxia about 2008 and 2010 was largely centered on motor manifestations. And our work at that time helped to recognize ataxia as a multisystem disorder involving cognition, olfaction, and also functional neuroimaging correlates. My PhD thesis at that time was focused on cognitive dysfunction in SCA3, Machado-Joseph disease, and cerebral damage was associated with damage of neurocognitive circuits and also olfactory deficits in our work. So at that time, we expanded the phenotype of Machado-Joseph disease with the recognition that patients with Machado-Joseph has the cerebral cognitive affected syndrome. When I start to work with this kind of symptoms, a lot of neurologists did not believe that patients with Machado-Joseph disease had cognitive affected syndrome. And nowadays, there are a lot of works on that a lot of disease, a lot of case, a lot of recessive disease that also patients had cerebral cognitive affective syndrome. So our group is very proud of that. We had, I started to the ataxia unit at Unifesp, together with José Luis Pedroso and Dr. Orlando there. Nowadays, the group have more than 1,000 patients with ataxia. So my experience at Unifesp helped me to learn a lot about the disease. And then I came back to Fortaleza, Ceará in 2012. And a year later, I was selected as associate professor of State University of Ceará. But unfortunately, at that time, we did not have an university hospital to increase our number of patients with ataxia. And at that time, I worked at Hospital Geral de Fortaleza. It's another hospital in Fortaleza, a very large hospital. And I started my work with ataxia at that hospital. Only in 2016, I was selected as professor of Federal University of Ceará. And there we created a unit of, initially a unit of neurogenetics. And Paulo Ribeiro Nóbrega is a neurologist, neurogenetic, specializing in neurogenetic, and we started this outpatient clinic at 2017. Only a year ago, 2025, that we created really our ataxia unit. So our unit is a little small now. We have about 60 to 70 patients with ataxia. Here is the location of my city, aqui, Northeast Brazil. Northeast Brazil has a specific demographic background, including high rates of endogamy and consanguinity in some populations. This increased the probability of recessive ataxias. We have a work published together with Laura Jardim at Parkinsonism-related disorders that showed that about 40% of patients had consanguinity history in our population. So it's a lot. And then in 2019, we started to make a collaborative study at Federal University of Ceará and also the Hospital Geral de Fortaleza, General Hospital of Fortaleza. I have, it's a small group. I have PhD students, Edvan here, and Paulo Ribeiro Nóbrega was my PhD student. Now he is a professor of our institution too. Stephanie is now with me as a PhD student. She is working with the Crohn's ataxia scale. I'll tell a little bit about this later. And so we are building a service of ataxia since the 2 years before.
Pedro, 2 minutes.
Regarding our, okay?
2 minutes, okay?
Okay. Regarding our results, we have about 50 patients with ataxia. About 60% of the patients are recessive ataxia. So we have much more patients with recessive ataxias than dominant ataxias. The most common recessive ataxia is Friedreich ataxia, then seborrhoeidoneous xanthomatosis, Arsax, Canvas, ataxia telangiectasia, Niemann-Pick type C, and so on. So our current research is organizing into 3 pillars: clinical scale adaptation, biomarkers, and epidemiology of the disease. Here on the left, we have our previous works with sleep disorders in Niemann-Pick type C, the validation of Schimmelmann scale for Brazilian population, the translation of Tran ataxia together with Laura Jardim's work. We work together a lot in this project. Now we are looking for biomarkers like nerve ultrasound evaluation, and also several biomarkers like neurofilament light channels. So our biomarkers was focused on these types of things. We all are looking for different profiles of patients, different phenotypes in our group of patients. And I again would like to say that I'm very glad to be here with you, and we are looking for having more work together. Thank you very much.
Thank you, Pedro, for this very comprehensive presentation about your story. It's very meaningful for all of us. Now we can move and go to the presentation of Marcos Vinicius de la Coleta. Is he here with us?
Yes.
Oh, great. So Marcos Vinicius Thank you for you to be here with us. Marcos Vinicius is also a neurologist working at Universidade Estadual do Amazonas in the northern part of the country in Manaus City. So please go ahead, Marcos.
Hello, everybody. It's a pleasure to be here. I born in the south of Brazil, but I live here in Manaus since 20 years ago. So we studied a few years ago our population with ataxia. Our genetic center is not still organized fully, so we could study our group of ataxia patients for in our outpatient service, and I will show you some characteristics that are different in our population in Amazon comparing with the other parts of Brazil. Here in Amazon, we have an epidemiological characteristic of SCAT2 predominance over SCAT3, which is different of the other series that are present here in Brazil. Following. Okay, what can I change? Oh, okay, thank you. We have some characteristics, geographic characteristics that would explain some data about genetic in Amazon that are not seen in other parts of the country. We have the bigger state of Brazil, but with this smaller population. So we have a very low population density, and our urban concentration is 52% of the population here in the capital, Manaus, and the other rest of the state with the more 2 million people. And the most part of this population, it's around small villages. And these small villages concentrate the populations with a high degree of consanguinity in some parts of the state.
1 minute, Marcos.
Okay, I would like to show you that we have some characteristics that make it difficult to the patients to arrive in Manaus. So maybe we have a lot of patients in regions that we have not conditions to achieve yet. So we can change. Our study published last year we studied 43 patients, and just to show you that the most of our patients was SK2, but I think that it's most important to have almost of our population non-diagnosed. Also, we have other variants or other ataxias that we couldn't find in our cohort. We can go to delay the slides, so we can pass through. Okay, thank you. We have a different approach of the population here. We don't have the same European consanguinity that we have in the south of Brazil. So we have this Amerindian population here that may be responsible for the characteristics of our population, and this made this region unique to study with haplotypes characteristics that made it very interesting. We can go ahead. I think we can go to the last one. So briefly, I'd like just to point that the Amazon region in Brazil is different from Northeast, is different from the south of Brazil in the genetic characteristics. And until now, our data published show that we have a lot to discover, and it's very important to be here and maybe contribute with other groups. Thank you.
Thank you, Marcos, for your comprehensive presentation. I like it very much. We can also talk a little bit later in the Q&A session, because we need to move now to the Bolivia presentation. This has been done by Eric Delgado. I'm not seeing him. It's he
I'm
together
here.
as a...
I'm here.
Oh, great, great, Eric, great. So Eric is also a neurologist, and he belongs to the Medical Center, Neurocenter at Santa Cruz City of Bolivia. Go ahead, Eric.
Hi, everybody. It's a pleasure to be here among all these great specialists. The main topic or the main message of my talk will be simple. Is to show that Bolivia is not completely absent from the ataxia literature, but evidence is extremely limited. We have clinical signs, we have a genetic report that I'm going to show you. The main thing is that when we review the literature, Bolivia appears mainly to isolate case reports, not to epidemiological studies. But as I show in the bottom of my slide, a recent Latin American meta-analysis found that many countries, including Bolivia, don't have publishing epidemiological study on autosomal dominant spinal cerebellar ataxia. So at this point, we should understand and see Bolivia as a country with illness, but not yet a systematic data. This is the stronger genetic confirmed report from Bolivia. It's a family who combine an SCA2 and SCA10 mutation. In this case, and his mother both have mutations, while a maternal uncle has only SK10. Clinically, the phenotype combined, as we already speak about it, slow saccade with typical SK2 and seizures commonly described as SK10. The author of this paper suggests that this rare co-occurrence could mean that these both alleles may be more frequent in Bolivia, but this remains only a hypothesis because we need population-based studies. There is also a second Bolivian report described 3 siblings from Potosí, which is in a department of Bolivia on the north. And they describe phenotype considered compatible with Friedreich ataxia. However, this report must be really carefully because the diagnosis was clinical based, and the author explicitly mentioned that genetic testing and nerve conduction study were not made. So I will present this just as clinically suggested of Friedreich, but not as molecular confirmation. Taking a close look here, we have some local numbers. In Bolivia, according to the national census made in 2024, we should have like 11.36 million inhabitants. And in our center, it's a private center, mainly, I think on the public centers, they will have a lot of more patients. But in our center, between January 2024 and January 2025, we identified 3,188 first-time neurology visits. Making more research, most of the patients were Parkinsonians or Parkinson disease. But we found 4 patients that were suspected genetic ataxia in this period after investigating and excluding more common acquired causes. None of them had the local molecular confirmation. One of the patients that I do follow up died recently with no diagnosis. And I think this illustrates the real world diagnosis gap. Patients are suspected clinically, but access to genetic confirmation remains limited. So,
Eric,
yeah.
1 minute.
Sorry?
1 minute, less than 1 minute now.
This is my last slide. We need multi-center register. This is our future goal. We already started preliminary conversations and email exchanges with colleagues from Peru to explore possibly collaborative pathway. But my final message will be that the absence of data should not be confused with the absence of the disease. That will be all.
Thank you, Eric. Thank you. So kind of you. We need to move now and go to the Chile. For Chile, Paula Safi will talk to us briefly again. Paula is a neurologist that belongs to Clínica Santa Maria at Santiago de Chile. Go ahead, Paula, please.
Thanks, Laura. It's an honor to be here. Hello, bom dia. Today I would like to present and give you like a brief appetizer, an invitation to open the international appetite for research in Chile. Next slide, please. The first message here is that the published evidence, as you see in the left of the slide, does not reflect what we see clinically. If you search PubMed, the evidence on hereditary ataxias in Chile appears scattered and limited, mostly sport reports and isolated families, as you can see there. But in specialized centers, like what you can see in the center of the slide, we see many more patients that are not presented in the literature. And these are the ones that we have already diagnosed, but much more are undiagnosed. And this gap is partially explained by the underreport of cases, lack of systematic approaches, and of course, of the lack of local access to genetic testings. Many samples need to be studied outside the country, and many patients remain undiagnosed. Next slide, please. But Chile is a place where genetic surprises can happen. And recently we discovered, and this is a great pleasure to show to you, 4 cases of SCA4 in 3 unrelated families with ataxia from Chile. This was unexpected because, as you know, SCA4 has previously been reported in mainly Sweden and in a Utah family. So our patients, as you can see in the ancestry plot, cluster as Latino and mixed, but they had the haplotype analysis of the same haplotype reported in the original families. So this finding is very important because it reminds us that population assumptions should not close the diagnostic process. Even in this admixed population like Chile, we may find diagnoses that we previously thought that only belonged to very restricted geographic or ancestry context. Next slide, please. Now, before, please. So many and much remains unsolved. And for this, I wanted to bring this example that is Chiloé, an archipelago in southern Chile with around 170,000 inhabitants. And there we identified 17 individuals with ataxia, suggesting a higher than expected frequency. However, even after repeat expansion panel and whole exome sequencing, we only solved 2 cases, one with SPG homozygous mutation and one with canvas, not in familial cases. So the familial cases still remain unsolved. So this leaves us with more questions and answers. Are we missing repeat expansions? Are we missing structural variants, founder effects, or mechanisms that are not captured by standard approaches? Next slide, please. So the take-home message in the next slide is that from Chile, the published evidence we know is limited. There's a large gap in diagnosis. There's a high heterogeneity, but the clinical reality is much more larger and richer. Chile can reveal unexpected genetic findings such as SCA4, and regions like Chiloé show that there are still things to be discovered. So Chile is not only a place where genetic testing is needed, it's a place where genetic discovery is possible. In this picture, I want to show you our new genetic group of a study of ataxia that has a multidisciplinary approach to these patients, and we are soon to publish the first Frederick ataxia guidelines for the country. Thanks a lot for the opportunity. Obrigada. Thanks a lot.
Thank you for you. Muito obrigada para ti, Paula. Fantastic presentation, very challenging, very moving as well. So we don't have time to go to so many good words that I want to say to you. Then now we need to move again now to Mexico. Our representative of Mexico today, there will be 2, of course, but in this section will be Miguel Angel Ramirez. Miguel Angel is here with us. Yes, we are seeing this. He's also a neurologist. He's linked to the Universidad Nacional Autónoma de Mexico and working at Mexico City. So, Miguel, please go ahead with your presentation.
Can you hear me?
Yes. You need to put your presentation as, yeah.
Okay, hello. This is Miguel Ramirez from Mexico City. I'm glad for this invitation. Sorry for my English. And I would like to thank to the organizers. Today, I will share with you 4 main points about our research. The first point is related with the minimum frequency estimation for ESCAS in Mexico. My institution, the National Institute of Neurology and Neurosurgery, has the largest registry of genetic neurodegenerative disorders in Mexico. This protocol update is focused in minimum frequency estimation, as well as the main clinical features of these disorders, specifically Huntington disease and ESCAS. These calculations are based in the Mexico total population according to the National Register in INEGI. For the ESCA2, the minimum frequency is 0.19 per 100,000 inhabitants. Mexico City and the state of Mexico has the largest count of the cases identified in all Mexico about this ataxia. ESCA3 have a similar picture with ESCA2. And however, the ESCA7 show low frequency throughout the country, but the state of Veracruz shows the higher frequency of this condition. Another estimation about the ESCA10 and ESCA17 show these global estimations, but Mexico City is the main entity that has the major number of these patients with these ataxias. As second point, I would like to share with you the origin of the ESCA7 in the state of Veracruz. Regarding this protocol, historic and anthropological assessment for ESCA7 in the state of Veracruz. 2 previous studies suggest that ESCA7 has an European origin. This research aimed to determine the origin of ESCA7 through two strategies, where the first strategy based on field study, civil and parochial records were evaluated, and at the same time, direct semi-structural interviews were performed. With this, a total of 791 individuals, both symptomatic and asymptomatic from 13 generation were identified. This is the map of the state of Veracruz, and you can see in blue color the principal regions that has a higher frequency of this ataxia. With this, we can build this large pedigree, and at the same time, we can identify the region of the population with this ataxia in Veracruz. As you can see, this approach allows us to trace the first family back 13 generations ago to the 18th century, and also shows how the families identified in different locations in the Veracruz region all come from the same origin or the same family. The second strategy was based in genetic markers, specifically the estimation of global and local ancestry. As you can see, the European ancestry was confirmed, and currently we're working in the local ancestry, and we want to share these results when already. And this work award the best thesis in the master's degree for Juan Carlos Guevara. The third point is about the qualitative research for SCAS. There's a scarcity of qualitative research on SCAS in general. We perform an phenomenological approach from interviews from 3 individuals. Qualitative research needs a little quantity of patients, and this is probably an advantage. We interviewed 3 individuals, 1 individual at risk, 1 caregiver, and 1 affected individual. With this, we focus in values, counsels, beliefs surrounding the disease, the diagnostic odyssey, emotional responses to facing the disease, the stage of denial, the impact of the disease on couples, changes in family relationships, labor and economic changes, lessons learned about the health disease process. Currently, this work is submitted for peer review. And for last point, I would like to share with you, we are continuing research in clinical and scientific perspective about SCA10. And these 2 recent publications regarding a clinical and functional MRI about the SCAs. We continue working in that, and specifically we found a high proportion of this ataxia in one region of Mexico, Aguascalientes state. We identify a minimum frequency about the 1.4 affected by per 100,000 inhabitants. These new cases and these new families of SCA10 are very close. These families are very close one each other. This suggests a possible founder effect, and we would like to determine the origin of the SCA10 in this region using the same strategy as SCA7, based on field study and based on genetic markers, as well as continue research with functional MRI. Thank you for this invitation. Thanks for my coworkers. Thanks for my collaborators from Facultad de Medicina, UNAM. And thank you to my collaborators from Instituto Nacional de Medicina Genómica. Thank you.
Thank you, Miguel. So now we can start our question and answer section. I will talk a little bit while I'm waiting for questions, just in order to, again, to address Miguel, please. Are you hearing me? Yes. I didn't say that your presentation was very nice. It was also challenging for us to follow, because there's so many information in this session. I would say this session was busy. And why? Because we have a lot of different countries from Latin America. So what we have in common, this question is to all the speakers that we have up to now. I have 2 questions. First, what is your feeling about Amerindian ancestries in relationship to your results, either in Manaus and in Amazon, in Mexico, and in Bolivia or Chile? In Bolivia, don't have, but we are expecting to. But in Chile as well, Paula have shown us intriguing results. This is the first question. So after that, I can go to the second one.
If I can start, that we should perform a specific study of haplotypes here in the Amazon to define this characteristic of Amerindian impact in our region. We just finished a study of haplotypes in Huntington's disease. And in Huntington's disease, our profile is different from the studies of the south of Brazil, and we have almost 30% of Amerindian haplotypes here in the Amazon, and almost all the European haplotypes in Huntington's disease are from genetic migration from the northeastern of Brazil, mainly from Ceará. Ceará is the biggest origin for some diseases here in the Amazon because of the historic migration here in Brazil. I think that we have a very unique condition here in Amazon linked with the other countries around the Amazon region. And it's a very, very particular population to study.
Mhm. Are you aware of the results by Mario Cornejo on haplotype studies in Huntington's disease in Peru? He has also
Yes,
results.
yes. They have a higher higher percentage of Amerindian than
Higher than
our
us.
results. Yes.
Yeah.
In our case, we only evaluate the haplotypes about the SK7 because the origin is very confusing at the first. It was suspected that it's of our European origin, but we would like to determine if it's possible to found the specific subpopulation. But we are working risk currently in this situation, and at the same time, as you mentioned, the SK10 for this region that we identify several families, we like to analyze with haplotypes, maybe using microarrays for trying to discover what is the origin of this ataxia.
Mhm. Yes, ataxia 10 unified us. Yes, it's something from the New World. Yeah. I don't know if Paulo or someone else wants to say. I don't know if Luis. Go ahead.
Thank you. So I think it's very important and very interesting question because as you are mentioning, you have done these studies in, for example, Huntington's, but in ataxia it's much more complex because you have so many ataxias, so you have so many haplotypes. You could have someone with the genetic markers for the whole genome that shows a mixture pattern with more or less Amerindian, but if you go to the specific haplotype for the region of interest, you could have anything. So for ataxia, it's much more complex, but much more needed because then you could discover many things. So I think that we should move forward in that way also in the region.
Thank you. I don't know if the Cuban people is here with us, Roberto or Luis. Otherwise, I can also present another question.
Yes, I'm here. We are here.
Oh, great. Oh, Roberto, go.
Yes, hi, Professor Luis. Maybe he's not here because he's in a place with unstable connection, but I'm available for comments, questions. Okay.
No, my first question was about if there is some impact of, I'm sure I know the answer, but I need to do the question.
Okay.
What do you know about the ancestry of your ataxia patients? If they have some impact of Amerindian, because Cuba is a little quite different from the other parts of the country.
Yes. Our study about the origin of the Cuban SK2 population has disclosed that our population has an origin in Spain. We made about 12 years ago an experiment comparing haplotype of the current patient with SK2 with a current patient in Cuba with current patient with SK2 in Spain. and we observe a high sharing, high concurrence of a haplotype of SCA2, and this was supported by our histological assessment, because we study the registry of the person in Cuba by several years ago, even in the two past century, and most of cases that had clinical history similar to ataxia had Spain surnames. Also, we had histological information about a possible founder of the population here in Cuba that was familiar of the people that create the Holguin city in the 17th century. Yeah, we have not evidence about the Amerindian origin, but from Spain, maybe is the main origin of the Cuban SCA2 population.
Thank you. Now we have another question.
Yes.
Done by Mario. Mario Cornejo is asking you all, how do you approach, the speakers, how do you approach an ataxia patient that, despite diagnostic effort, remains undiagnosed? Like Paula.
I think I can jump in because we don't have that much of diagnosis. Usually, what patients came to the clinic, we first go to the study to degenerative diseases. We do a familiogram in the charge. We do cognitive assessment, and we refer patients to physical assessment. And we talk to the patient as far as we can go. A lot of patients decided to go to different countries to get the diagnosis. I remember I have a patient whose sibling went to Brazil. His brother get a diagnosis of SCA2. He came back to me and said, "Well, my brother get this diagnosis, so mostly I cannot sure. Maybe this is what I have. They got it from his mother. Also have symptom, never diagnosis. So we usually explain patients a little and encourage them to go physical rehabilitation and symptoms treatment after they move forward. But it makes hard in case of genetic consult. This patient have a descendant. He have like a daughter and a boy too. He said, "Well, what are the odds of my descendant have the disease?" And I explained what we already know. For instance, the other patient that I was talking about, she passed away, and she have two daughters, and she never get a diagnosis. But the two of daughter were symptomatic. So we usually give what we know and accompanies patient through the process.
Someone else wants to say a word about it?
Yes, of course. So I want to break the question before the answer. So for every patient, I wanted to share a resource in the chat. We gather a guideline for patients with ataxia, with any case of ataxia. It's in Spanish, but we did a conference, and we asked the patients before the conference to ask every question that they have on ataxia. And after the conference, or in the conference, we made a focus group with the speakers to answer every question that the patient had. So for every patient that comes now to the clinic, we can give this guideline and solve these questions that they all have, and they are concerned because no one else gives answers to their questions. So what I want to address here is that when a patient comes with or without the definite diagnosis, they have a lot of questions, anxiety, and many times this diagnostic odyssey has been very painful because some colleagues tell them, I don't have anything for you, or I can't help you, or don't come never again because I can't do anything for you. So first of all, I wanted to share this guideline, and also I wanted to share that despite having or not the diagnosis, we have always to give company and comfort to patients. What I always try to do is don't leave them alone. Never, never. Even if you can't get the diagnosis, don't leave them alone because it's very frustrating for them. So you have to give company, you have to give, as Eric mentioned, this physical therapy, rehabilitation, or contacting them with a group of patients that have the same condition. Like first focusing in the patient, the suffering patient, more than the genetic diagnosis. And in my personal experience, what I try to do is to collect the genetic samples and store them in case that I could find the opportunity to send it to a scientific opportunity to address the diagnosis in a proper way. But first the patient, then the diagnosis, and try to collaborate with others if you store the samples for future studies. Thank you.
So we have three persons to talk. Wonderful, Paula. Mario raises his hand, and after that, people from Wales and Amalia, maybe they can talk a little bit. Mario.
Just a brief comment on, can you hear me, right? Just
Yes.
a brief comment online, fully agree with Paula. I just want to highlight three aspects. So we as clinicians have always to speak with the truth, to manage expectations of patients since the very beginning, to be clear about the challenges on diagnosis and treatment, not after the diagnostic efforts, since that very first visit, so the patient and the family knows what to expect, and not always the path. It's an easy path, right? And as Paula mentioned, if we cannot treat as physicians, we can accompany them, we can support them, we can prevent complications. There's always things to do as clinicians, and we have to avoid messages that unfortunately many patients and family receives, that there's nothing to do. Thank you.
Thank you, Mario. I received this comment by Ataxia Aware Wales. I don't know if the person wants to open and share. Otherwise, I can read.
Laura, if it's possible, I also have a comment, a brief comment about the
let
comment.
me try
Okay,
before
sure.
in Wales someone to talk, or maybe I can also only read. They wrote, in Wales we have the syndromes without a name. The acronym is SWAN clinic that patients are referred to, and also the Always Medical Genomics service that can be referred to. Maybe those experiences can be better known for many of us, just in order to get inspired and do something similar in our centers. Then moving a little bit, Roberto, just a little, Amalia Maranhão suggested or have asked, now she asked, I don't know if she wanted to open her microphone. Otherwise I move forward. Amalia wrote, have you thought about the possibility of having a Latin American hereditary ataxia registry? That format could build a registry more immune to political fluctuations. Isn't it time for scientists to take a step forward to protect knowledge already collected against the wave of discredit in science? I can start replying this. Everybody can say a word. First, that we have a registry already started inside the AGI. Maybe we can develop something more related to the Latin American characteristics. Second, I truly believe that scientists, researchers, and physicians, we are all committed with beneficence, non-maleficence, autonomy, and justice. And because of that, we are all committed with equality in between people. Maybe we are the most important people that make peace in the world. And this sharing of information is an example of that. So I suppose this is very important. Who else wants to say something to Amalia about this registry? I don't know if Thomas is there or in AGI or... If no, Roberto?
Yes, thank you. Sorry, I didn't find how to raise my hand in the system. I just want to support the comment of Paula. This is very important. And here in Cuba, with the Cuban population of ataxia of SK2, we have some experience about that. Really, we have created conditions for the social care of such patients, for the close support between them and also with the researchers and the physician. We have created program for the rehabilitation, for the application of physiotherapy even in the community, nor with the need to move to the hospital or specialized center for rehabilitation. We have also promoted the social care, social attention of the more vulnerable cases. And we made some activity. We create a WhatsApp group. During the pandemic, COVID-19 pandemic, we established a tele assistance of the cases because, as you know, her loss of mobility increased the problem, and it works very well in our condition. Then I agree again the Paula comments, and I say this very important to do accompany all cases in this situation.
Thank you. Thomas? I learned
Yes,
that.
I think the question was related to a registry. I think this is a great question, and a registry, a international Latin America registry is desirable and should be a goal, but I think it's not easy, and there are a number of hurdles that maybe we can discuss possibilities in the final discussion, because it's a bit complex.
Great. So now I would like, concerning this, the care of patients with or without diagnosis, I also suggest you to read the comments by Ira Eberhardt, because she's saying that there is an European project that provides patient journeys for rare neurological disorders. This is in the chat, so please go ahead and go there and take a look into that. And I would like to address a last question to the speakers, because now we heard many experiences from Spanish-speaking clinicians and researchers concerning the participation on the clinical trials to come. We have already developed a Brazilian version of the patient-reported outcome measurement, which will probably anchor the follow clinical trials to come. So it would be extremely important to develop a Spanish version, usable to many different countries. What do you guys, fellow guys, would think about it? Either Paula, Roberto, Eric, and Miguel Angel, as well as Irene and other guys who are Spanish-speaking communities here.
Yeah, it would be very useful to translate it. We should work on that. Yes.
This would allow you to participate in clinical trials to come as well. Yeah. So I hope you take this opportunity, this moment to meet one each other and maybe develop that. I don't know if I don't, someone else wants to say that word.
Yes, yeah. I also to support your comment, Laura. I'm agree. If the number of patients, the population that we have in Latin America is a great opportunity for this collaboration and for the harmonization of all of protocol of all of clinical trial. We are working here in Cuba, as mentioned you, with some neuroprotectant agency, neuroprotectant drugs, potential neuroprotectant drugs. And it could be very interesting to make multinational Latin American clinical trial with the other populations in the region. It's very important know that.
So if there is any other comment that maybe I missed something.
No, but still we have 1 minute and just a
we have a
very short comment.
Comment.
We have not only neurologists on the call, but also representatives of patient organizations. And I just wanted to make a focus on that. We have Baher and Ataxia do Brazil here. We have from Wales, is it right? Ataxia Ware. We have a Mexican MAFAC and also Ataxia Association of Argentina. So, and I'm not sure how you all are connected, but this is a good possibility, a good platform to connect for the patients. Yeah, because both sides have different functions, and I think it's a good opportunity.
Yeah. Nice suggestion. Maybe a federation, yeah, of patients or organization would fit very well after this meeting.
AGI has a working group for patient organizations, so you are welcome to contact us. And yeah, hello everybody. We are now back to our last session, and the chair for this session is Thiago Rezende, who is an active member of AGI and was also on the planning committee for this meeting, which turned to be really a great event. And thank you, Thiago, for taking over for the last session as a chair. Thank you.
Thank you, Ira, for your kind words. So we will start our section 3, the last section. And our first speaker is going to be Jonathan Magaña. He's a geneticist from Mexican National Institute of Health in Monterrey. So, Jonathan, the stage is with you. Thank you.
Okay, thanks a lot. And first of all, I would like to thank the organizing committee for the invitation to participate in this important forum. And today I will present the current status of spinocerebellar ataxias in Mexico, with a particular emphasis on spinocerebellar ataxia type 7, as we likely have one of the largest case series of this condition worldwide. The next, please. This effort began more than 2 years ago, driven by Dr. Luis Velázquez, who is here with us today. Our first step was the development of a molecular diagnostic method based on multiplex PCR analyzed by capillary electrophoresis, capable of identifying the 5 most common autosomal dominant ataxias worldwide. This diagnostic approach was validated in collaboration with other laboratories in Europe, with University College of London, with Porto University, Barcelona University, among others. And then we later expanded this panel to include Friedreich's ataxias. With this platform, we can obtain a reliable diagnosis within just a few hours, serving as an effective first-line screening tool. Next, please. Okay, through this diagnostic strategy, and given that the National Institute of Rehabilitation serves as a national reference centers, we identified the distribution of ataxias in Mexico. Initially, spinocerebellar ataxia type 2 represents 45% of cases, followed by spinocerebellar ataxia type 3, spinocerebellar ataxia type 7, type 1, type 6, while 19-20% remain undiagnosed. Interestingly, all spinocerebellar ataxia type 7 patients were originated from the same geographic region. The next, please. As shown here in this map, spinocerebellar ataxia type 7 are concentrated with an area of approximately 1,200 square kilometers in the central region of Veracruz in the southeast of Mexico. And we identified an extraordinarily high prevalence. For example, 1,300 cases per 100,000 inhabitants in one community. The name of this community is Tlaltetela, and 337 per 100,000 in the community of Tuzamapan. These numbers are dramatically higher than the global prevalence of approximately 1 per 100,000 inhabitants. Given that several of these communities have fewer than 6,000 inhabitants, we reported prevalence at the municipal level. In this sense, the next, please. In this sense, throughout the population genetic analysis using 4 markers linked to spinocerebellar ataxia type 7, and we identified a clear founder effect. Further, in this slide, we analyzing using 17 Y chromosome markers that reveal that the mutation likely originated from migration events involving population from southern France and northern Spain, specifically in the Pyrenees region. Okay, the next. Based on these findings, we established 2 main clinical protocols: symptomatic diagnosis and presymptomatic diagnosis. Both are accompanied by genetic and psychological counseling. And a difference to the Mexico City, in this population, presymptomatic diagnosis has been less successful, mainly due to the socioeconomic limitations, as many patients are unable to complete this protocol. This highlights the need to bring these programs directly into these communities. The next, please. Today, or currently, we provide specialized clinical follow-up, analyzing disease progression using standardized scales such as SARA, INAS, BARS, among others, and correlating these findings with genetic data. And we need better the studies for analyze different biomarkers. The next. With this, we are investigating peripheral biomarkers in patients' blood samples, such as you shown in this slide. We analyze biochemical markers such as oxidative stress markers, inflammatory markers, and we analyze different omics biomarkers. transcriptomic, proteomic, and metabolomic profiles. The goal is to identify objective markers of disease severity for spinocerebellar ataxia type 7. The next, please. And to better understand the disease and explore therapeutic alternatives, we have developed experimental models for spinocerebellar ataxia type 7. These include nervous system models expressing either wild type or mutant ataxin 7 protein using human Muller glial cells and human neuronal cells. The next, please. As you shown, these models recapitulate the formation of ataxin 7 protein aggregates. We have different models such as inducible models and constitutive models for the ataxin protein, mutant ataxin protein. And with this, the next please, we using these models and we are identifying key mechanisms associated with spinocerebellar ataxia type 7, with the pathology, such as toxic RNA, mutant protein aggregation, transcription dysregulation, cellular senescence, among others in our laboratory. But the next is very important that these platforms allow us to test therapeutic strategies. In our laboratory, we are developing different nanocarrier systems for drug delivery systems or biomolecular delivery platforms, particularly RNAi interference-based therapies. The next. In this slide here, you can see a micrograph of our biodegradable and biocompatible nanoparticles. We have nanoparticles around 200 nanometers for drug delivery systems and around 100 nanometers for RNA interference systems. These systems are designed to halt or potentially reverse the disease progression. The next, please. At least at the in vitro level, we have demonstrated with different treatments the reduction of mutant protein aggregates, decrease apoptosis, and improved cell survival. And then, okay, and this was a brief overview of our work, and we would like to sincerely thank all members of our research group and all co-workers in Mexico and other countries, and especially the next, we thank to the spinocerebellar ataxia type 7 patients and their families. Thank you very much for your attention, and that's it for me. Thank you.
Thank you very much, Jonathan. Wonderful presentation. Very nice, your SCA7 model. So time's urgent, so we are going to move right away to our next speaker, which is going to be Mario Cornejo. He's a neurologist. He's one of the coordinators and planning personnel for this meeting. And he works in Peru in the Instituto Nacional de Ciencias Neurológicas in Lima. Mario, please.
I think it's now, right? Thank you, Thiago, and the organizers and AGI for this meeting. I will, over the next 10 minutes, share with you something a little bit about our path, advancing ataxia research and care in Peru. And I have no disclosure for this presentation. This is our center. We are located in Lima, the capital city. Our institution, believe it or not, was founded in the 17th century. So we have by now 326 years of age. And the neurogenetics division where I work in started back in 1995. So we are almost 31 years of hard work on ataxia and other neurogenetic disorders. As you can see here in the map, we are working mostly on repeat expansion disorders, and ataxias are a significant group of all of them. And since we are a national reference center, we receive patients coming from all over the country, from the north, from the south, and even from the Amazonian jungle of Peru. So these are the milestones. If we can start with the working in ataxia in Peru, I should come back to the 1910 with this Ibero-American initiative called RiverMov. Laura briefly mentioned that as well, because it was an initiative conducted by Professor Anthony Mattia from Spain, but give us the opportunity to meet many people, many researchers and clinicians across Latin America. And I have to highlight from them, Brazil, the Red Neurogenetica and Laura Jardim, because that was the very first moment when we meet each other. Another important point for us was the very first moment when we could implement our first genetic testing for any dominant ataxia. It was for Machado Joseph. The diagnosis was implemented back in 2012 with a brief case report that we presented in a local journal. But the things change over time, because since 2012 up to 2015, we were part of the Red Neurogenetica with full support of Laura Jardim's team. And that opened us many opportunities, including the opportunities to attend scientific and also patients meetings, and also training opportunities in genetics as well, all of them in this lovely city that provide us tools to move forward on ataxia care and research. That's why when we started and organized a very established ataxia clinic since 2015, and by 2019, we were open for collaborative research, and also with local funding from our local Peruvian agency, we were able to organize the first Latin American school for ataxia that took place in Lima, and many of you were visiting Peru by that time. By 2020, at our center, we started with this DNA bank that until now facilitate and provide enough support for performing collaborative research, especially those with genetic biosamples. And we are not only based on Lima anymore, the capital city, so we are working now as a national network. So we have satellite centers in the north, in the south, in the central highlands, and we are expecting also to start working in the Amazonian jungle as well. By 2023, we were recognized as an Ataxia Center of Excellence by the National Ataxia Foundation. And since then, we have a more organized data and a better registry of the number of ataxias that we follow up in our center. And just from the last year with my academic institution, Universidad Científica del Sur, we are starting on several collaborative research studies, especially regarding SCA10, that, by the way, is the most frequent dominant ataxia in our population. And as Laura mentioned, we also are starting since 2024 with the predictive testing program. Mostly by now is in Huntington's. We are just starting on the spinocerebellar ataxias, the dominant ones. And hopefully for the future, over the next years, I can show you some results. These are the map about the number of cases that we have with diagnosis. Obviously, spinocerebellar ataxia type 10 is the most frequent one, followed by SCA2 and SCA7. But we also have a significant and increasing number of other disorders, including many recessive ataxias as well. And if you can go and to check this pie, it's also important to keep in mind that about a half of all our patients still are undiagnosed. The majority are dominant ataxias, and we are increasing the number of recessive ataxias, mostly because we are starting collaborative projects to performing exome genome sequencing for these patients. what we were working on over the past, I think, 7 years, we are learning even from case reports like this ataxia with oculomotor apraxia case that was diagnosed after almost 40 years of following up, and with about 10 different diagnoses over these 40 years. And also this lady with ataxia telangiectasia, focusing not only in her, but also in the increased risk of cancer, not only for the patient, but also for the close relatives. We were also working on systematic reviews for some genetic ataxias, and I would like to highlight the work that we have across ataxia telangiectasia in our country, the work we have for ataxia de Friedrich ataxia across Latin America, and our recent spinocerebellar dominant ataxias systematic review across Latin America. Just recently, we are also collaborating with David Pellerin from Canada. And as you all know, SCA27B, it's kind of a common dominant ataxia now, but keep that in mind, it's not everywhere. About 150 undiagnosed ataxia cases in Peru, only one case was positive for SCA27B. So things are kind of a little bit different. Now we are working in a tremendous study that we are planning to conduct a cohort of our NASCA10 study. We have over 76 families diagnosed with SCA10 now in Peru. This is a collaborative effort that we are doing with Professor Birgit Schul across Stanford, and the name of our study is the NASCA10. For those who doesn't know about the Nazca lines, I strongly recommend to check that. And Eric Delgado, Professor Eric Delgado for Bolivia, in his presentation also mentioned about the possibility of to start working together in an alliance for diagnosis and also for research in inherited ataxias. Well, I won't read these conclusions, but really I want to highlight the importance of, across this path, I would like to highlight the importance of mentorship and training. It's important, international collaboration, capacity building, include research in your clinical work, support from academia, and obviously it's always important, funding. And we just want to end with this philosophy that we have in our center, one family in search of other families. I want to thank all the neurogenetics team. I want to thank all the family of the Ready Neurogenetica. This picture is from the USACH study that was a collaborative study with the Brazilian colleagues. Also, Thiago is also there, and a little bit younger, all of us a little bit younger. And also people from Germany and from Israel, Professor Georges Sequeiros, many other clinicians and researchers that are collaborating on supporting us in many aspects, including genetic testing now, and all the supporters, both from our country and also internationally. Thank you so much.
Thank you very much, Mario. Very nice presentation. Right now, I would like to invite Nicolas Tomarruga. He's a neurologist from Uruguay. He works at the Centro de Referencia Nacional de Defectos Congénitos y Enfermedades Raras in Montevideo. So Mario, Nicolas, please.
Thank you very much for the invitation. It's for me a great honor to be part of this organization, especially coming after someone as known and in this field as Mario Cornejo. So I will try to keep to the schedule. This is an epidemiological update on hereditary ataxias in Uruguay. So to start, we needed to make a not so short timeline. In March 2019, we started an ataxia clinic in Hospital de Clínicas, and in October 2024, we presented the first results regarding especially SCA3. Meanwhile, in November 2022, it was created the first adults rare diseases group, the anterior one was for children only, and we are expecting to present in the upcoming months the second Uruguayan report. So this could be considered a sneak peek, a trailer of what's coming, and I think there are very interesting data. So when we started with this, it was like looking through a keyhole, and we say, okay, we have a landscape we're watching, and it's very similar. This is the initial data. I don't want to lose much time here. It was made in collaboration with the UCL Queen Square Institute group. Especially want to thank Dr. Holden, Dr. Pellerin, and Rawan Keilsanov. I probably said the last name wrong. And we found as a particular pattern with a very high prevalence of dominant ataxias and very few recessive, probably because almost all the patients were over 25 years old, and many of them were studied with a general gene panel of ESCA1, 2, 3, and 6, and 27B. We didn't have any 27B, so it was a prevalence of ESCA3 that it was very high. And this is the newer data. This is from the rare disease group, where we have younger patients. Many of them come from the pediatric group, and we have access also to the panel, but also to exome sequencing. So we can see that that's probably affecting the results. And it is important to say that we have a 90% of diagnosis, probably because when the colleagues send to the center, they want to send to be sure they are sending an ataxia. So probably that's a bias we have in the results. I think it's very important to see that the autosomal dominant, it's really different and very complex. We have SK13, SPG9, SK48, and when we consider the global etiologies, there is a high prevalence of Friedreich ataxia. We have 2 patients with omaveloxolone nowadays, and then the rest are more uncommon ataxias. So when we consider both groups and all the information, this is the information for 46 families. There are no related patients in this group. So for a 3 million people country, I think those are interesting numbers. There is a high prevalence of SK3 followed by Friedreich ataxia, but then you have a very varied landscape when you consider the rest of the diagnosis. So we consider that after looking through the keyhole, we open the door, and what we see is that, yes, there is a prevalence. There are more common ataxias than others, but there are different presentations and different diseases. So the takeaway messages could be, we are a historical point where diagnosis is linked to the technology available. Uruguay has a diverse landscape with a high prevalence of SK3 and other uncommon ataxias, which are limited by the access to molecular studies. And rare ataxias, when you consider them as a group, have a prevalence that compels us to consider them in daily clinical practice. And constant epidemiological updates as this one and like this conference and working together keeps us alert to do the diagnosis. This is the referral center. My friends didn't want their photos. They are very shy, so I only put the names under. And thank you very much for this opportunity.
Thank you very much, Nicolas. Right on time. So our next presentation, it's going to be from Irene Paradisi. She's a geneticist from Venezuela. She works at the Venezuelan Institute for Science Research in Caracas. Her presentation is recorded, but she is going to be alive with us in the Q&A. Thank you.
Soy Irene Paradisi del Laboratorio de Genética Humana del Instituto Venezolano de Investigaciones Científicas. Voy a hablarles de la genética epidemiológica de las ataxias en Venezuela. Se han descrito más de 49 subtipos distintos atribuidos a 37 genes. Todos los subtipos muestran diferencias étnicas en su frecuencia y su distribución. Se ha reportado incidencia de 3 por 100.000 para las poblaciones europeas y la prevalencia global es de 1 a 9 por 100.000. En el continente americano no hay datos uniformes de prevalencia debido a la ocurrencia de distintos efectos fundadores que han producido cúmulos génicos o agregados geográficos con altas frecuencias locales. En el Laboratorio de Genética Humana del IBI, desde el año 2002, hemos estudiado 12 subtipos de ataxia en familias provenientes de todos los estados del país. Encontramos que el origen de procedencia de las familias es muy amplio en todo el país y estimamos una prevalencia global de 4 por 100.000. Sin embargo, con una frecuencia inusual de distribución comparada con otras poblaciones, siendo la 7 la más frecuente, seguida de la 3, la 2, la 1, la 10. Y hay un efecto, una fuerte agregación geográfica para la ataxia tipo 1 y la tipo 7. En este mapa de Venezuela observamos la amplia distribución de todos los subtipos en casi todos los estados del país, pero se diferencian entre sí por la prevalencia de cada tipo dependiendo de la región geográfica. Por ejemplo, para la ataxia tipo 7, los dos principales estados de donde provienen las familias son estos dos estados del occidente del país, que sin embargo no comparten el mismo haplotipo en fase, lo que pudiera llevar a sugerir que existieran dos efectos fundadores para esta ataxia en esta región del país. En el caso de la ataxia tipo 1, el 30% de las familias provienen principalmente del occidente del país, principalmente del estado Monagas, una pequeña proporción de este estado central, Miranda, y en este caso todas las familias de este subgrupo portan el mismo haplotipo en fase, que no está presente en los individuos testigos de la población. Esto lleva a sugerir la presencia de un efecto fundador único para este subgrupo de familias. En cuanto a la ataxia tipo 10, muestra una extensa distribución en el país con estos dos estados del oriente del país, Anzoátegui y Sucre, donde vienen la mayoría de los casos, y de este estado occidental. Todas las familias detectadas hasta la fecha en el país comparten el mismo haplotipo en fase, que es el mismo reportado para los casos de América y el este de Asia. Hago énfasis entonces en que hemos encontrado 6 subtipos distintos hasta ahora en el país, y siendo el 7 el más prevalente, y aunque el lugar de origen de los antepasados es amplio en el país, hay cúmulos génicos específicos o agregación geográfica fuerte para los subtipos 7, 1 y 10. Efectos fundadores seguidos de fenómenos de deriva génica han conformado la estructura actual de la genética epidemiológica de las ataxias en Venezuela. Muchas gracias. Soy Irene Paradisi, del Laboratorio de Genética Humana del Instituto Venezolano de Investigaciones.
All right, so thank you, Irene. So we are just checking our last presentation. So Luis, please.
Hello, thank you for having me. Greetings to my fellow Latin Americans, and thanks to the organizing committee for letting me in at a very short notice. So briefly, I would like to introduce you into these two projects we are running currently at the neurogenetics department at UCL London. Some of you has been sending samples and clinical information already, but I would like to update you on these two projects. So the first one is GWAS. So we are running a genome-wide association study for SCAS, polyglutamine SCAS, basically to identify genetic modifiers. And then basically we are using the GCRA microarray covering like 1.2 million genetic variants in the human genome. So there you can see the numbers of samples we already collect per SCA type. And then on the other diagram, you can see that about 80% of these samples are coming from Europe, and we have only like 10% of these cases coming from Latin America. On the other hand, we are doing deep sequencing using Illumina MySeq i100, looking at the repeat length and repeat composition to study somatic instability and to look at the effects of interruptions in the somatic instability and the correlations with clinical disease severity markers. So this is basically project 1. And then project number 2, we started working on that a few months ago. Ira, next slide, please. Yes, thanks. This one is basically about DRPLA. So you know DRPLA is an ultra-rare disorder. And then I know that in Latin America, there have been just a few reports on DRPLA cases. The question here is, what are the milestones in DRPLA progression? This is a longitudinal study, case control as well. And the main objective is to characterize the natural history of DRPLA in both juvenile and adult onset patients. And we are studying a broad range of biomarkers or candidate biomarkers using imaging, using quantric Simoa, ultra-sensitive ELISAs to detect candidate fluid biomarkers. So we're using recent technologies like O-Link and Nulisa, which is a technology that allows you to detect proteins at very, very low concentrations in the range of attomolar concentrations. That's 10 power to minus 18. And then in this study, 70% of the samples we had are from European countries. And from Latin American countries, we only have like 1% of the total. It's like only one patient coming from Brazil. And it would be great to increase these numbers. And on the other hand, we are studying genetic biomarkers as well, using this technology you can see there. Next generation sequencing, PCR-based, PCR-free with Oxford Nanopore to quantitate the repeat length, the interaction patterns, and do the analysis of the somatic instability and they correlate with the clinical presentation. So in the next slide, my final and key message here is that we need to increase the representation of patients with from Latin America because of the different genetic backgrounds and environmental exposures from Europeans, Asians, and Africans. And that this is very important to provide access to Latin American patients to these platforms in support of the design and conduct of clinical trials. So that's the key message I would like to address and invite you all to be part of these studies. Here at UCL, we can provide you with support on the projects you are currently carrying out. And we have all the infrastructure here on hand with sequencers and a state-of-the-art technology. Thanks. Thank you all.
Okay, so thank you very much, Luis. Very nice project. So we will move to our last presentation right now. We just got the video. So this presentation is from Professor Wilson Marks. He's from University of São Paulo at Ribeirão Preto. It's the place I'm working right now. I am chaired by USP in Unicamp in Campinas.
Ribeirão Preto, University of São Paulo. I initially like to thank you, the Ataxia Global Initiative, for this great opportunity, and also to Professor Laura Jardim. We have a large number of patients with ataxia, about 2,000 patients, and the first group of studies that we carry on is about Canvas, the RFC1 gene. We have tested about 400 patients. We found B allelic dysfunctions in about 120 patients, and from these patients, 45 patients are from our own institution. We are developed studies that involve the genetic aspects, neurological neurophysiology, deep phenotyping, image aspects, neuropsychology, ophthalmological manifestations, and otolaryngological manifestations. About the genetic aspects, we have a large number of patients that have unusual or new motifs. We don't know if they are pathological or no, or not, and we are studying the real significance of these alleles. We, on the neurological aspect, we are doing trying to do a deep phenotype analysis of these patients. We are applying clinical scales. We are trying to correlate the clinical manifestations with the expansion size and the type of expansion, the motif expand the patients have. About the physiology, we are applying a specific special nerve conduction techniques to understand how the peripheral nerves are involved. We are also trying to do some small nerve fibers techniques and also some evoked potentials to try to do a deep phenotyping also about the image studies. We will talk more specifically in the next slides. We are also trying to understand the neuropsychology of these patients. We are doing cognitive evaluation. We are doing some neuropsychological evaluation. Professor Pedro Tomazelli is leading these studies. And we are also working with people from ophthalmology and the otorhinolaryngology to do deep phenotyping of the eyes and the vestibular manifestations of this disease. Regarding SCA27B, we have almost 50 patients diagnosed in our center, including a large family with some generations affected. So I think it is be very interesting to try to see how the disease goes from generation to generation. We are trying to do some deep phenotyping, including clinical neurology of these patients, the MRI, neurophysiology, OCT, electroretinography, nystagmography, and we are also doing some skin biopsy to cultivate fibroblasts. Initially, we will try to study the coenzyme Q10 in these patients. This is a study that we are just beginning. And then we have a large amount of studies about image. Most of these studies are led by Professor Thiago and the group from Unicamp, led by Professor Marcondes. What we are trying to do is one of the studies we are doing is to evaluate the pattern of damage in genetic and acquired sensory neuronopathy. We are going to study the dorsal root ganglia techniques. Thiago is developing some protocol. Our intention is to develop a dedicated imaging protocol to evaluate dorsal root ganglia and its projections, to develop advanced computational tools to assess the DRG and spinal cord, and to identify patterns of structural damage that could help us to diagnose these patients, if it's genetic or not, if it's genetic to direction to which genetic is that. We hope with these studies we can provide diagnostic support from idiopathic forms using machine learning techniques. Here is we have an example. We can see here the dorsal root ganglia of a control, a dorsal root ganglia of a patient with pre-high ataxia, and another patient with an acquired sensory neuronopathy. What we are trying to do is to develop an automated dorsal ganglia and the nerve root segmentation that will help us to, as I told, to identify the genetic and non-genetic patterns of the. Well, this is another study we're doing, an imaging toolbox development. We are trying to study the cervical spine and to identify some markers in the C1 to C3 levels that could help us to identify markers of neurodegenerative disorders. We hope that with this automated analysis, we will be able to identify these neurodegenerative diseases as a diagnostic tool, and also to use them in the studies of the natural history of these different diseases. I think this is This is going to be very, very important in the near future. Well, and here I think we are trying to put everything together. We are going to study the precentral gyrus, the thalamic radiation, the spinal cord, the medulla, the pons, the midbrain, and the cervical spine, and to put everything together. And with the help of the AI, to try to identify patterns that will help us to identify different neurodegenerative disorders, including Friedreich ataxia, SCA 1, 2, 3, 6, and other diseases. As I told before, this will be another tool. I think it is more global tool that will help us to direction to the right diagnosis at the beginning, and also to understand better the diseases, and also to use these tools to study the natural history of these disorders. We know that these studies will be very important from the treatment studies for the new drugs, new treatment options that are arriving. So we think that this also will be a very, very useful tool. I should remember again that most of these studies are led by Professor Thiago, and also we are working together with people from the company led by Professor Marcondes. And finally, I'd like to talk about the SCA2 ataxin-2 expansions. This is not an ataxia study by itself, but Professor Marcondes and ourselves, in several other institutions of Brazil, we studied the correlation of the size of the expansion of ataxin-2 and as a risk factor for ALS. And then we found that the intermediate ALLs are probably risk factors for the development of ALS. Now there was a recent study correlating the size expansion of ataxin-2 with age of onset of TTR amyloidosis. We also have lots of interest in this disease. It is a very prevalent disease in Brazil, and we are now studying to see if in our population we have some link between ataxin-2 expansion and the age of onset of TTR. I think this is a very important tool to use in these patients. You know, we have now several options of treatment, but we can just treat these patients when the disease starts. We don't know exactly how or when we should start to follow these patients in short period of time. And we think that if we identify factors that are related to the age of onset of the disease, it will be much easier to start treatment when the disease really starts. So we are now in development of this study. So I think that's these are the studies we are doing with Ataxia now, and I thank you again the Ataxia Global Initiative and Professor Laura Jardim for this great opportunity. And sorry again for not being present, but their company changed my flight schedule at last minute. Thank you very much.
All right, thank you, Ira, for showing the presentation. So we overstepped it for some minutes, the section, but we still have some time for Q&A. So I invited all the speakers to come, and anyone have some comment, questions? If no, I have one comment. So we saw here, I mean, we might agree that the diagnosis access, it's, I think, the biggest challenge in our field, especially here in Latin America. But I would like to know what is the second, or what is the next other resource that it's important that we are missing here in our region, and that might, I mean, doing difference from the treatment, from the patient care.
Hi, Thiago. Okay, I think we need work together, no? I think is a challenge, but we have enrichment culture in health of ataxias for different types in neurologists or molecular biology and other disciplines. But I think we need articulate these collaborations between our region. No, I think we work independently, and we need work with different expectatives or focus in different objectives. And I don't know, it's very important. The next steps for the treatment is very important. We work with palliative treatments, no? And it's possible begin to work with other treatments, more specific treatments, molecular treatments, pharmacology treatments for develop new structures and benefits for the patients. Okay, Mario.
Good. Yeah, Mario, please.
I would only summarize some aspects that I think are important in terms of starting collaborative efforts. And I think over the past 3 years, we were discussing about why we cannot have more successful collaborations, because we have successful collaborations, but compared to all the things that we are doing, clearly they are not enough. So looks like there are a lot of isolated efforts rather than something in coordination with all together. And in Latin America, at least there's something happening that when we start a collaboration, we start with mistrust. And so before the very first feeling that many people in Latin America have when you start collaborating is mistrust. So you need to overcome this first feeling to start with trust and developing trust over time with another colleague, with another center before collaborating with that person. And I probably, it is just my sense, but for example, in north-to-north collaborations, they start collaborating with trust. If you lose that trust, that's your responsibility. But the very beginning is that. I think that is the big problem that we have in Latin America, and probably we need to overcome that. And the best way to overcome that is to start with very small things. For example, let's do something together. Let's write, a perspective together. Let's collaborate very specific thing, and let's see how it works first. And based on that previous experience, probably we can develop more things. I was really thinking over the past 3 years about the strategies, not only discussing the problem, but that's some thoughts.
Yeah, I totally agree with you. And I mean, we have to take lessons, right, Mario, from the existing initiative like ESME, like RedSCA and TrackFA, the people starting working with trust, and then they put something on next steps every time. So I think this is a good beginning. Yeah, I saw Luis Velasquez. He was raised his hand. So Luis, do you have any comment? No.
Okay. Yeah.
Okay. Good.
Thank you so much for to participate for the opportunity to participate in this meeting. In line with the most of the speaker, I would like to express that it could be very important to advance in to do a clinical registry of ataxia in Latin America. I agree with Thomas in relation to that we need to face in different challenges, but I think we need to advance
in this registry, especially in we can include different clinical information related with different clinical scales, such as SARA, INAS, cognitive evaluation, imaging, molecular biomarkers, biochemical, epidemiology, electrophysiology, and with the objectives to advance to a clinical intervention. But I think this opportunity is very important, and we need to advance into creating this registry. And I think that Laura can be organizing to this collaboration between other colleges from the different countries of Latin America. I think this is a good opportunity, and that we need to advance in this topic. Thank you.
Yeah. Thank you very much, Luis. Yeah, very important comments, actually. Yeah. So I'm not seeing anyone else. Oh, Thomas, please.
Yeah, thank you, Luis, and all others for the presentation. I think that was very impressive, and this is an unbelievable large spectrum of activities. Luis, I completely agree that, we briefly discussed that already earlier, that a large registry would be desirable. What we need worldwide, but in particular also in Latin America, is a structured collection of data. Structured collection not only of data, of longitudinal data. And start with the simple things. If you have patients have the SARA and maybe one prom every year, and collect that and make it available. And this is doable. And the question is, what is the best strategy? I think one can be very ambitious and say we need a Latin America registry, and this may be too ambitious because there are a number of legal, organizational hurdles, funding, and all these things. One could also take another strategy, and is more a bottom-up strategy, to create a lot of local registries, which are very similar because there's harmonization of the data collection of the clinical outcomes, and be very open for data sharing. And this is more realistic. And the AGI has already published guidelines for registry, which variables should be collected. We could update that, and we could counsel you and advise you what is the best strategy. But this is something that then, if you do it locally and be open to data sharing at a later time point, this is something that can be quite easily started, and started very soon. Whereas a very large registry is something where you need discussions and funding, and that will take years. But this is just a suggestion. We can discuss that, but I believe it's an opportunity, and I would repeat again and then stress that the collection of structured longitudinal data, I think this is essential.
Yeah, thank you very much for this comment, Thomas. I totally agree. I think we should work more on simple things first and complexing it in later stages. Yeah, I think this is important. Irene, please go ahead.
Well, thank you very much for this opportunity to share with all of you. It's a very updated scenario of what we have in Latin America. It was very interesting and very enrichment for all of us. And I agree with Mario about the starting with small collaboration, specific collaboration. It's more realistic than perhaps have a very, very ambitious collaboration. And this conference bring us the opportunity and the important contacts with all of the community in Latin America. Thank you very much for all of you.
Thank you, Irene. So we have any other comments on your
Yes,
question? Yeah, go ahead.
Yeah, I think I also completely agree. Realistic way forward is the bottom-up approach, starting with smaller, feasible things, very specific things. And there was today in the discussion one really excellent suggestion, and this is the Spanish version of the PROM ataxia. I think this is very important. I will talk tomorrow about the clinical scales, about SARA. This is all well established. And traditionally, these clinical scales, the ClinROs, have been the primary outcomes in clinical trials. But this is not a law. This is changing. And we will have clinical trials where we have a PROM as the primary outcome, or maybe a combination of two. And the PROMs are directly related to the patient. So the challenging thing is that people in each different cultures and countries must understand it. And so you have to translate what is not necessary with the ClinROs, because most doctors speak English. And so this is something that you should really do. And we should take concrete next steps to organize how we can do that, and the AGI will be happy to support that and help.
Yeah, and this is really important. And maybe, I mean, we can ask it for the patient support agents, because, for example, FARA, I know FARA, it's translating a lot of the scales for different languages, and I'm pretty sure they might have some of versions from FAR's ADL, other PROMs, and maybe even SARA. So Miriam, I don't know if she's still online, but
I
we
am,
could
yes.
check. Oh, yeah, please,
Yeah,
Miriam.
yeah. So we have a couple of those scales translated, indeed, that we can find, and you can find on the website of MAPI. And we are always open to collaborate. We have some non-validated other translations of other PROM that we can share as well. But for the validated ones, most of them are available at the MAPI Trust.
Yeah. So we have part of the work already done. Laura, please go ahead.
Thank you. I didn't understand actually. Miriam, do you already have a Spanish version of PROM? I didn't get the point.
Well, some, like the ADL, for example, this is something that has been translated, activity of daily life questionnaires. And in other studies, we did do internal translation, so they are not validated, but some work was leveraged. So I don't see why people need to reinvent this. We have it in Spanish and even for Portuguese, in Portuguese for some. So very open to share what we have as a resource that we can share openly, and other items need to go through MAPI, and there are some royalty fees, unfortunately. But for the ones internally, we are happy to share the resources.
It can be helpful, definitely, because as according to our experience, I say our, meaning the South Brazil and northern part of Brazil, we have adapted culturally the patient-reported outcome measurement ATAXIA, developed by Jeremy Schmaman, to Brazilian usage, adapting this to the way we talk Portuguese in the south as well as in the north, in the collaboration with Pedro Braga Neto. So I would stress the suggestion again that I actually have made, that the guys here who are Spanish-speaking persons coming from Argentina, Bolivia, Chile, Peru, Mexico, and Cuba and Venezuela, maybe, to start talking to one to each other in order to foresee how to build an adaptation that can be feasible for all these different communities, because patients needs to understand exactly the same thing according to each item of the PROM ataxia. Of course, this PROM ataxia, which is the most used PROM instrument so far, under usage nowadays. So this is my suggestion or challenge to these guys. But if you have already a Spanish version written internally or not to Europe-speaking Spanish people, this will help, I guess. Maybe it can be done together. As a matter of fact, the Brazilian and Portuguese, meaning mainland Portugal, way of speaking. My feeling is that we speak very differently in between both countries. So this difference must be addressed as well.
Yeah, I agree. And don't underestimate how the patient organization can facilitate and help in those translations. This is work that we've done this work before. We collaborated with local patient organization. I do see a couple on the call today. This can be really a great support. So I would probably, it's a circle and a great way to collaborate to facilitate those translated PROs.
Yeah, good. And Nicholas?
Hello? Do you hear me?
Yeah,
Okay.
go ahead.
No, I just wanted to add that please don't forget Uruguay in all of this. We're a very small country between two giants. And yes, we are only a few. We have a few patients, which has many inconveniences, but many perks for that. We are interested in achieving their diagnosis to make our contribution to the general study, and please feel free to contact me, to contact our group. I have seen we released the first SCA3 with over 15 patients like 7, 8, 9 months ago, and the new reviews still show an older study with only 2 SCA2. So please contact us, we can share, and we want to share the data. Is important for us and important for the patients mostly.
Yeah, for sure. I mean, sorry for that, but of course, I mean, we are talking about all the countries here that could be involved. Yeah, and every contribution is valuable. So anyone else for comments?
Thiago,
Yeah, please.
if I can present me and talk a little bit. I am Katiana. I'm from ABI. ABI is a Brazilian patient associate. And we have some website that has some information about ataxia. I put this in the chat, and we have to work to do a register from patient. So if you want to talk to us, I will be very happy to share this information and collaborate.
Yeah, thank you very much, Tatiana. This is very important. I mean, working with you guys, it's my PhD just happened because you guys, and I'm very grateful. So it's all important, and FARA as well also help us a lot. So it's important working together in our field. Mario, please.
Yes, Thiago, just a brief comment regarding how can we start with this idea of for example, developing local registries in each center or in each country, for example, at least one, right? Perhaps we can, I'm thinking about possibilities of having a sort of working group for developing a simple guideline. So each center, even novel ones or some that are already collecting samples or recruiting participants for research or for clinical care, to follow simple and clear steps to collect data and to share basic things that many of us probably will think that is kind of obvious, but honestly, it's not like this. And probably if we come up with a simple document, very easy to read, and we circulate that minimum between the centers that are represented here, I think we'll be having some progress. And really, as you know, if there's no team or no person in charge of overseeing if that goal it's moving forward, probably nothing gonna happen. That's why I think it's important to have a kind of working group or a specific group with this task. And so this team can have this task.
Yeah, thank you very much, Mario. I think, yeah, we have some good ideas. We definitely put that on paper to follow and move forward. So I'm finishing this section right now. I invite Laura to close the meeting, and thank you all. Thank you the speakers for presenting their sites here. Thank you.
Actually, I need to say thank you for all of you. AGI attendees, speakers, because today we have 17 Latin American ataxia leaders graciously summarize. They make this strong effort of summarizing 4 to 10 minutes the local characteristics of their institutions and their patients today. We saw how local realities are, and I would say even diagnostic proportions differ in between us. Of course, this was to be expected given the characteristics of our continent or continents here in the global south. But the quality of the data from each of you that you shared with us today was very, very high and sincerely deserved longer and more in-depth sessions. Maybe it's something to be organized in the near future. So besides this, I also want to thank you for your efforts in participating. Facing, for instance, 2 power outages, so 2 power blackouts right now in Cuba due to embargo, I suppose, participating from boarding lounges, boarding in the airport, as in the case of Professor Wilson Marques, and so on. So I appreciated very much your efforts to sending your data, maybe sometimes videotaped or not. So because of this, many ideas appeared today. For example, perhaps we could write to the authorities of our countries demonstrating the need for financial support for transnational research in Latin America. I've heard here that we wanted to collaborate with each other by doing performing, including data about SARA scores in the registry, whatever, but all of this needs also concrete possibilities, and the concrete possibilities stands for financial support. We need that. Perhaps we can also write 1 or more papers on later after this meeting relating to this topic, reporting the experience we had today. Perhaps we can even develop 1 or more ways of register patients in our continents as well. So there were many other ideas. I am definitely sure that the today's session helped to publicize these centers of Latin America to the AGI community. And I hope it also may help to promote partnerships in between different entities, either institutions and people, mostly people as well. We are all here committed to seeking, as I said beforehand, beneficence, non-beneficence, autonomy, and justice for the people we serve, for the people with ataxia. And I'm pretty sure that justice will truly prevail when all people will have access to healthcare and to participation also in health policies. So I believe that today's session, however modestly, has helped in the advance of care of people with ataxia in our continents. We are very grateful. We are very grateful to the AGI to giving us support to present this conference, this online conference. Without the AGI structure, it was not possible to do this in the morning of today. And reminding you that AGI is an institution that aims to facilitate the clinical development of therapies to come for the ataxias, okay? But the struggle continues. Yeah, I hope that many of you will continue this conversation after that, behind the scenes, I would say, that much scientific research will emerge from these conversations in between you, and that we will repeat this type of conference on other continents inside the AGI, and also that Latin American people here will find a path to integrate. Okay, we saw today that it was the desire of many of us. So the today section was recorded and will be available at the AGI website. So I invite you to go and come back there to this meeting, videotaped meeting. And by saying that, I thank you all, to Ira, to Thomas, to the speakers as well. And for now, I declare the session closed.